Good morning to everyone. Uh, welcome to Cloud Community Days, day 3. We are really excited for today's session because today is the last day of Cloud Community Days. So, for the last 2 days, we have been uh, hosting Cloud Community Days, and it has come to the end of Cloud Community Days. So, today is the last day, and today we are going to follow the theme serverless and DevOps. So, I'll just quickly run through the agenda for today's whole conference. So as you can see, this is the official website for Cloud Community Days, and we have started the conference from 17th of June. And as it is 19th of June, so today is the last day. So for the first day, we followed the theme cloud and cloud technologies. Then yesterday we had sessions around AI and ML, and today we are going to focus on serverless and DevOps. So here are some of the speakers who have already spoke to our conference, and there are two more speakers who are going to speak today. So these are the list of speakers we have for Cloud Community Days. Also, this is the agenda for today. So uh, from 10:30 onwards, we'll be starting the first session. So the first session will be by Leena and Murugan. So the session will start from 10:30 a.m. In between every session, uh, I would request all of you guys to put your questions in the comment box so that the speaker can go through it and answer most of the questions at the end of the session. So after Leena and Murugan session, then we have Aaron Paul from Microsoft from 11:15 a.m. Then we have Mamta Jha from 12 p.m. Then we have a lightning talk by Niharika from 12:45. After Niharika's talk, we'll be splitting up for the lunch break and we'll be joining back by 1:40 p.m. So, as you all know, we are having an exciting game time, which is quiz. So, there will be some fun activity for all the audience. So, please, guys, join us back by 1:40 so that every one of us you can join for the game time and participate for it. We have exciting prize for the winners. I just mentioned about that after later. After the lunch break, we'll be starting off with the afternoon sessions. The first session will be by Vishal Biani from 2 p.m. Then we have Nancy from 2:35 p.m. Then we have Hiroshima from 2:50 p.m. Then we have Anisha from 3:05 p.m. Then we have Minaka from 3:25 p.m. And at last we have Sayantika from 3:40. So after we complete all the sessions, we'll be sharing the feedback link with all the audience. So guys, you can fill up the feedbacks. With your feedback, we can go back and um, retrospect and come up with better experience for our future event. So please, guys, fill up the feedback link at the end of the event, and also in the feedback link, you'll be asked to mention whether you need a certificate or not. So you can choose either of them. After that, we'll be announcing the winner for the quiz time, and also as most of you will remember that we had a referral program for the whole conference, so we'll be announcing the winners for that as well. So, guys, if you are one of the winners, so you have to stay till the end of the event so that you could know if you are the winner or not. So that will be all for the agenda. So now I'll show you the learning resources which we have for the conference. So we are maintaining a Git page with all the speaker slides and the learning resources. So I'll show you where is it. So this is the learning page we are following up. So it's the link is conf.me/ccdlearn. So we'll be showing the link. So you can go through this page. So we have exciting and free learning resources, and we have free ebooks as well. So you can go through them. We have category wise learning resources for you. So we have from AI and ML, then we have for DevOps, we have for Kubernetes, then we have for serverless, and here are the speaker slides. So from day one itself, we are maintaining all the speaker slides for all the speakers. So you can uh, go through all the speaker slides, whichever you want. So you can find them under the day-wise sections. This is for day one. Then we have for day two, and the speaker slides for today will be updated here under day three serverless and DevOps. So that's all for the learning resources page. Also, guys, before we start off with the sessions, I'll show you the housekeeping rules so that there could be a proper decorum and all of us could follow the rules so that there is no hodgepodge in between the sessions, people asking for the slides or asking questions. So I'll show the rules for the whole conference. So, guys, these are the housekeeping rules we have for the whole conference. So all these sessions will be recorded, and we'll be sharing the recorded sessions and the speaker slides, videos, learning resources, all of those in the post-event mailer. So because a lot of people will be asking about if the sessions are being recorded or not, and how to get those speaker slides. And also in between these sessions, we'll be sharing those speaker slides through the comment box. As I mentioned, like you can go through the learning resource page through this link. It's con.me/ccdlearn. Uh, After every session, there will be a Q&A session. If the time permits, it's totally up to the speaker if they want to take it up or not. Maximum of 3 questions they can take up. So guys, please post your questions through the comment box so that the speaker can go through them and answer to most of the questions. So, so guys, this is the uh, code of conduct we have for the conference. So I'll just read out the lines. This event is dedicated to providing a friendly and welcoming experience to all attendees, regardless of gender, sexual orientation, disability, ethnicity, or religion. All participants are expected to display a positive community spirit by exercising consideration and respect to all that attend. Unacceptable behavior or harassment of event attendees by any firm will not be tolerated. So, guys, you can go through the whole code of conduct from this link. It's conf.com/code of conduct.html. As I mentioned, the whole learning resources can be seen here. The link is here. So, just telling about the quiz time. So, the quiz will be starting from 1:40 p.m. So, we have a very tight schedule for the whole conference. So we'll start up from 1:40 p.m. and the top six winners will be getting uh, 500 rupees worth gift voucher. So guys, please come back after the lunch break so that we can uh, start with the quiz and you can participate in that. Also, guys, we would love to hear from you. Like, how are you experiencing the whole conference? So you can make a tweet of that from uh, Twitter using the hashtag hash CC Days Online. So please make a tweet and let us know how you experience the whole conference. So here are the community partners for the whole conference. So we have a bunch of community partners for Cloud Community Days. So these are some of them. Also, this whole conference is being sponsored by Microsoft Azure. So we are really thankful for Microsoft Azure for sponsoring this event. Uh, so this is about the housekeeping rules and all the other things. So without wasting further time, we'll just start off with our first session. Cool. So for the first session, we have Lina and Murugan. Uh, so I'll just quickly add them to the screen. Hi Lina, hi Murugan.
Hey, hi Rohit, Elena.
Yeah, how you all doing?
Doing good.
Good.
Good,
Lina,
good.
uh, Lina, are you able
Yeah.
to hear us?
Yes. I was muted.
Okay, cool.
Oh, okay.
Yeah. Okay. So thanks a lot for joining us for today. So today is the third day of Cloud Community Days, and we are following the theme serverless and DevOps. So you guys are the first speakers for today's session. So Lina and Murugan, I would request you to give a quick introduction about both of you, and you can tell what your talk is going to be about, and then we'll start off with the session.
Uh, okay. So uh, the session is basically about mainly about how to use Azure for setting your pipeline and deploy continuously to your different environments. But just rather than just showing this is what you can do with the tools, we are giving a intro of why you need to apply DevOps principles and CD practices, so that you are aware why you are using the tools. So we are giving an intro why the tools are designed and why it is designed in the way it is now, and then we are jumping on to how to do that. Anything to add, Murugan?
No, I think yeah. The power of Azure DevOps, right? People must be thinking it's a Microsoft tool and then it's only for .NET. No, right? Uh, I want to start with like telling like how this has changed over a period of time, and then how it's gonna work with any other languages: Python, Node.js, Ruby on Rails, Java, you name it, and it supports it. Yeah, that's what we'll be diving into.
Okay, that's cool. So I think Lina, you are going to start first. So I'll share your screen to the screen so that you can start. So, Lena, your screen is live.
Okay.
Yeah.
Okay, so we've already given an intro of what you are going to talk about. So I myself, Lena, I'm the CTO of a small product startup called Good Karma. We recently renamed it to Practice Now. We've been iterating on the names. That's a different story. I can talk about that on a different context. I've been working with my friend had co-founded a company called Multunas around 10, 12 years back, which was a software consulting company. I've been doing that we ran that for close to 10 years, and then we jumped onto our own product. So all the things that I'm going to share, mainly the learnings that I have been doing for the last 10, 12, or maybe 15 years of software industry. So I'm more interested in the engineering aspect of the product development. I do write code. It's a small startup that I'm working with, just 2, 3 people. So I'm the one who writes the most of the code. So I break the production, I fix it. So I know the pain of dev and ops. So most of the I'm sharing most of my experience in the talk. Now Murugan will give an introduction about himself.
Okay. I work as assistant director at EY, mainly focusing on Azure cloud environments and then providing DevOps as a service solutions. And I contribute a lot to the community. I really want to thank CodeOps and Hari, taking this meetups and conference to this level. I think they're doing really great job because I see I think Rohit is being I think he must be working like all 24 hours from past 3 days. Really appreciate CodeOps and Confab on this. But I am actually I love DevOps, right? So somebody Manoj was mentioning to me like even if I wake you up from the sleep and I can talk about DevOps. So uh, these pictures I'm very proud to put it with the godfather of DevOps, Patrick DeBois, and John Wallace is the kind of first American who got into DevOps, and Jez Umble is the father of continuous delivery. And please, you can join the local meetups which we do in the Bangalore. It's just a free of a cost, and we get to learn a lot.
Okay, so so like I mentioned, we can talk about all the tools. All the tools helps you to move faster, but unless you understand why you're using the tool, you will not be able to leverage the power of it. So before we jump on to the demo that Murugan is giving, we're stepping back and thinking, okay, why is it required, and what value we can leverage from the tools that we are providing. So. So the one of the biggest problems in the software industry is the last mile problem. That there's a funny saying that 90% of the time is taken by the 90% of the work, and the last 10% takes the next 90%. And that is true. You can see that happens all the time. Even you think, okay, it's just a small change, it takes all the time, and then it doesn't go into production. Okay, and that's a problem that we see everywhere. And just quoting Mary Ann Topper-Bendick from the book Lean Software Development, which was written maybe a decade ago, even more than that, you can think about how long it takes for you to change one line of code, maybe color of a button you want to change to something else, and how much time it takes. If you really go into different people and ask this question, you can see that you can hear different timelines people say, like say from 1 hour to even 1 month. Okay, and I asked this question in a conference, and I was really surprised. Maybe a few months back, I asked this question, and I saw that many people raised their hand for say 6 months and above. That was really just one line of code. We are talking about just one line of code, and that really happens. And why is that, right? The main problem is that change is a constant, right? We always fight with change. We think, okay, this is a final, but the next day we hear that, okay, that has to change. And we really don't cope very well with changes. I think maybe it's a human behavior. We are used to habits. And then when something changes, even a small change it comes as a bottleneck for us. Okay, and that happens when we develop products also. We think this is a final thing. We know that things will always change, but we have to appreciate change and adapt to it, right? And so rather than going into why is the problem and stuff like that, I think it is better to look at what Jess Herbal, Nicole, and Gene Kim has done in the last few years as part of DevOps research and assessment. What they've done is they've taken, I think, 50,000 data points and then looked at how different teams behave and what does matter, why they have different kinds of results depending upon different kinds of teams. So what they looked at is they looked at mainly two things. One is the throughput, that is how frequently a team deploys, and how frequent how much time does it take for a team from commit to production. The moment you commit the code to production to the code base, I mean to your repository, how much time it takes to move it to production. And the next parameter they looked at is stability. How stable the teams and the environment is. Like, it's not about that things don't go wrong. Things always go wrong. Okay, but how frequently different teams adapt to those failures, right? How much time a team takes to restore a service, and how frequently the failures happen. Okay, and this all thing they put it as a matrix. Okay, and the lead time, the change failure time, and then availability, and then you can look at it in three aspects. One is the lead time is mostly about development, change failure is about the deployment, and availability is about the operation. Okay, and they categorize the teams into four types of on the based on the performance. They categorized into four different types. The top one is the elite, and that is a small fraction of the entire group. And then comes high, medium, and low. Okay, so for me, what was the most interesting fact in this was the change failure rate. If you look at the difference between elite and the medium, is that all these teams, elite, high or medium teams, they have a 0 to 15% failure rate. So there is no much difference in that. That means, okay, even elite teams make mistakes, but the difference is how frequently, how much time does it take for them to actually restore that the service or fix that problem. Okay, and how frequently they are making changes to production. So they have the same amount of failures, but they make more changes to the production. Okay, or any environment for that matter. And if you look at other factors, the elite and high teams are much more than medium or low. Okay, but what is the difference? What are the factors for this elite and high teams to behave in this way? Okay, there should be something different in the way they are doing things than compared to others, right? And first and foremost, they always experiment, right? They try to do, rather than making major changes, they try to do small experiments with the customers. So they always first they always work with the customers. They try to understand what they want, and then once they understand what they want, to make sure that their understanding is correct, they try to deploy experiments into the environments, and then really try that with the customers and see how they behave, react to those changes. Okay, so they always experiment. But for a team to experiment, there are a few things that is required. One is that adapting to the lean way of doing things. Always do things in small batches, and also make sure that you have only reduce the number of working progress items, rather than having trying to do too many things at the same time. Focus on few things and do it really well. And then always work with the customers, try to understand how they what they want, that what their problems are the things that we developing and deploying, is it really solving their problems? Okay, that's all about lean. In the lean philosophy, customers comes first, right? It's you may we may have our own interests or thoughts about how to do things, but if the way that we are suggesting doesn't solve the customer's problem, there is no meaning in that. So keeping apart our interest and our thoughts, okay, really try to observe customers, talk to them and find out what they want, and try to do it all the time, try to improve the product continuously. Okay, that is the lean software philosophy, and a set of practices to support that. And I'm sure almost all of you are familiar with all these terminologies. But when you combine these practices together, and it really works for the philosophy, and that's all about it. For example, um, if you have a very tightly coupled architecture, which is very rigid, and it is very difficult to make changes. And even if you understand what customers want, you will not be able to deliver in the way that you think it should be, right? So you should have, starting from the architecture itself, how do you manage databases? Those are the databases and architecture are the major pillars of the things, and then that is the one we think is difficult to change. So even there we should have practices which will help you to manage it in a way that even there you can do small increments rather than a big bang change. Okay, so the small batches are the main thing that is a key for this. But what should include in the small batch, after talking with your customers or working very closely with your customers. But so when we talk about all these DevOps, everyone says, okay, it's good, but it doesn't work for us because we are regulated. We are not, our product is not simple, our product is different, and we have too much legacy, so on and so forth. So I'm going back to the research, DORA's research again. So in that, before jumping on to this, one of the earlier companies which showed us that you can really do continuous delivery is Amazon. I don't know how many have heard of this, but I think the stats this published in 2011 is that Amazon website go through changes in every 11 seconds. Okay, so in every 11 seconds there is a change in the set, and Amazon is one of the most regulated company. Okay, because it's not a simple website. It's not a they have their financial and everything. It's a lot of regulations they have to go through, and if they can make changes in 11 seconds, why can't a small team, say a team of 10, can make changes at least once in a week or multiple times in a week, right? So it's not actually about the domain you are in. It's more about the way you work, right? Or the way we work, right? We have to change the way we work, and we have to adapt to these changes to make even legacy code base. We can make small changes, and then over time you will be able to make faster changes to that. So going back to the DORA result, it talks about it. These are the domains that the industries that they spoke to or they got the data from, and it includes financial and other industries also. So it's not just about the technology companies. Even others can do it, and it doesn't matter what environment you are in. The number of employees doesn't matter. Okay, it's all about the culture or the way you adapt to making changes to the software, or the way you approach how to make changes to the software that you are building. Okay, and that's it from me. I think I have given a very high level overview of why DevOps is required and what changes it can bring into the business. I will hand it over to Murugan now.
Okay, sure. Thanks, Ina. That was a good introduction. Um, okay, so we kind of understood what is DevOps and why and principle and practices, right? I'm going to dive into how Azure DevOps is going to help us here. Let me quickly share my screen. Rohit?
Uh, yes, Murugan, your screen is live.
Okay. Um, so yeah, so DevOps pipeline basically talks about, like, when you have a requirement, right, and how are you actually going to manage that entire life cycle. So with Azure DevOps, right, and the beauty of Azure DevOps is it's just a one tool, and you can actually manage everything there, right? It's not just your tool for your automation, and it actually starts with your Azure board. This is like your Jira board or your Agile Scrum board. And then the development, I mean, Microsoft has a lot of development tools, and VS Code is being highly used, and Visual Studio. And you check in the code and to the Azure Git, Azure repo, and then that triggers the CI pipeline. And CI pipeline does a lot of things, like it takes a source and it installs all the necessary packages, and it builds the project and it runs a unit test. It also does the SonarQube code static analysis, the security test using Veracode or some other tools, and it creates a artifact, right? See, once the artifact is created, our code is ready, then we trigger the CD pipeline, the release pipeline. So in the release pipeline, it actually picks up the artifact, and we talk about infrastructure as code. That means the infrastructure should be provisioned on demand, right? Don't keep your infrastructure running forever. Unnecessarily, you'll be paying more money for that, right? So you have your infrastructure code is ready, and then provision it in the within the pipeline. So once the environment is ready, then deploy your code, then run your functional test, security test, and load test, and so and so. And so and from there you promote it to different environments. I've just in this picture I've just shown only four, but you can deploy it to like thousands of environments. And thanks to Cloudscape, I've used the Cloudscape tool to build this particular image design. Okay, let's get into the demo now. So this was I was referring to Cloudscape. Okay, as a first thing, right? Whenever you get a requirement, um, we need to have them as a backlog. In my past consulting experience, what I've seen really is the fundamentally people do mistake is, like, they don't refine the user stories, they don't estimate it well. Because of that, they're unable to deliver at the given time. And then once they deliver it, product owner comes back and says, you know what, I don't see what I asked for, or you might get a lot of bugs. So to start with, uh, this is how Azure DevOps looks like, and you see a lot of tabs here, like the boards, and here you can have your all your work item. This is your Scrum board and your backlog. So backlog as starts from epics, and epics under that you'll have a features and then user stories, and within the user stories you'll have tasks, right? And each task can have a number of hours, and then the priority, effort, and things like that. And obviously you'll have your sprint here, and you can use the multiple frameworks here. I'm using Agile Scrum, but otherwise you can use Kanban, you can use a plain simple board, and a lot of the other options. And you have another option called queries. So here you can actually get a custom result. Like, I want to know how many items are in progress state, or how many items are there which have been shipped, and which we or how many bugs we got, and all those things we get it here. And moving on, so for example, let's say, right, somebody doesn't have I mean, he would never started with any creating a pipeline, and how can actually they get started? And the beauty with this is, without even scratching your head, you can actually create your pipeline within less than 5 minutes, right? So for that, you will have to log into Azure portal, Microsoft. This is a cloud portal, and search for DevOps Starter. So So this is like a starter kit which helps you to build the basic template. Now I've selected this, and this gives you multiple options. So one thing, keep in mind that Azure DevOps is not only for the Microsoft tools. So this works for any language. So you can see here it's .NET, Node.js, PHP, Java, even simple static website, Python, Ruby on Rails, wow, Go, C, and then you bring your own code as well, right? So let me choose a Python here. I want to deploy a Python sample Python application. I'll click on next, and here this gives you template. Okay, which framework are you using? This is nice. So I'm going to select Django. And what kind of application is that? Is it a simple web app, and then or you have containerized it? I'll say simple web app. I just need to give a name. Python. I'll just give a config. And what I'm doing here is I'm saying, okay, go create a project called config, Python config in my uh, Azure DevOps organization, right? So Azure DevOps you can create multiple organizations within the Azure DevOps. One is like it's with my name. Otherwise, within your company you can create multiple organizations, or you can have one organization, and within that you can create multiple projects, multiple teams, and things like that, right? And this will take a few minutes to provision. Uh, to save the time, I'm going to go to the one which I already provisioned. So once this is provisioned, you will see something like go to the resources. So once you go to that resource, once you actually click on that, so this particular the what we did, like we just did like 5 clicks, right? In that 5 click, say Microsoft Azure has done a lot for us. So what it actually did is it took a sample Python code and it actually uploaded into a Git, which is Azure Git, and it created a pipeline here. You can see here there's a pipeline, a CI pipeline has been, continuous integration pipeline has been created, and it also ran the build pipeline, and we can see that how many ran. And then we also have a release pipeline. So CI is basically work still create your artifact, but CD is where you deploy to your production environment. And not only that, within this time it also created your one web app, right, platform as service, and it is deployed that sample code to here. And see the another beauty, right? And monitoring is very important, like Lena mentioned, right? Your feedback is very important, so it creates your monitoring as well. Now if I browse this, and I should be able to see my sample code as being deployed and which is running. And it is like you can consider this as a production application which is running. Oh, success! Yeah, this has been running now. Now I'll show you how we do it. Right now, let me click on this one. Go to this sample. So this takes me to my Azure DevOps. Here we just saw board, right? Let me take you through the repos. Here we keep all our code, and this is Git. You could use TFS as well, but Git is like more it's used. In this we can see we have the application, the Python application here, and like I mentioned, the infrastructure as code, right? So if you want to deploy anything to Azure, so use ARM templates. So don't log into portal and create something. So instead have everything scripted. That's what the script we see. And then another key important thing, like Lena mentioned, like your automated test is very important, very critical. So in this sample, we have written some unit test and then some of the functional tests as well. And Azure DevOps gives you options like where you can actually see who all committed, how many commits happened. Like you can see that there's so many commits happened, and you can also see the branches, who has created the branch and how many branches have been created. So basically, the one principle is you create a short-lived branch. Don't create a branch which is like going to stay for like months together. And tags, sometimes you don't want to create a branch, but you can just create a tags as well. I'm not created any. And pull request, this is very important. Don't commit any changes directly to your master. Don't assume that I don't make a mistake, because humans make a mistake. So make sure you create a pull request as somebody sees it and then they approve it, right? And this will show how many pull requests has been created and active, completed, and if somebody says No. Yeah. Okay. Now what happened is our code has been uploaded to Git, right? Azure repos Git. Now from there, we want to build a pipeline, right? So as a pipeline, if you come to the pipeline section, you see this pipeline. Under I have this one continuous integration has been created, and you saw that's a green, right? Green tick mark here. That means it's a success. And I did a 4 commits. That's why you see a 4 build here. Now let me go to. I'll show you how does the pipeline looks like, right? So pipeline is basically you take any language. So what are the steps you take? You consider it's a manual, right? And you want to deploy your application, and what are the manual steps you do to deploy the same thing? You're going to put it into the automated way. So now to deploy this Python application or to create a artifactory, as a first thing I need to create a task saying that, okay, which version of Python I want to use. Okay, that task is done. And second one, I say, okay, use, install the dependencies. Okay, cool. And then next I have here, run the unit test and publish the unit test results. And I want to archive that, artifact, the folder which I'm going to deploy it, and archive the test as well, so that this test can be run as a functional test, once after the CD. And we also have a ARM template, like infrastructure as code. I'm copying it to this folder so that I can my release pipeline can pick it up. This is how the CI pipeline looks like. And here, when you have some passwords, so you don't hard code it in any of the task, right? Instead, use a variables section, and then you can actually lock it so that it won't be visible. Now there's a trigger option here. You can say the moment I commit a code, there should be a continuous integration should be run. Okay, immediately the CI should run. So that you can modify here, and you can also filter which branch to run, which not to run. And you can also schedule not only when I committed, even the nightly build as well. You can schedule it. Some of the other options where you can configure your day, your format, and things like this. A retention policy, how long you want to retain your your build. And when you come to the history, it's basically, this is good thing is when somebody makes any change, you can actually come back here and see who made the change and why they made the change. Because one principle is, whenever you make any change, please make sure you put a comment so that people can actually see it, right? So once you pipeline is built, you say, okay, queue this pipeline. Okay, so what it's going to do is, and it's going to start running my pipeline. Now CI pipeline, if you see here, it is manually run by Murugan. I just clicked it. Otherwise, if I commit it, it'll show automated. And from which branch, and as the build is happening, just now it started, the build is queued. So the who's executing your build, right? So Microsoft as the cloud agents. So that agent will actually will do the job for you. So you don't need to install anything. But if ever you feel like, I want to have my own agent, you can still have your own agent locally. You can create it. Now, moving on to this one, on the releases tab, let's say that the CI is done, right? Or we need to do the release part of it. Now, within the release, and here you can say, I'm saying, okay, go pick up that artifact. And here I've told, okay, enable the continuous deployment. The moment the CI is done, immediately you start with CD. But you can actually disable as well. In some cases where you want to have a gates, you want to have any approvals, you can actually do that. So what happens here is, in my release pipeline, I want to deploy to one environment, which is dev, and you can actually clone it, telling that, okay, now deploy this to QA, deploy this to production environment, like that. So you can just copy from one to other. Now here you can have this. I can say, okay, I want to do a manual deployment or release deployment. And like I said, if you want approval from anyone, you can say that, if it wants to move from production to UAT, we need approval from a release manager. You can select their name. And you can also, another beauty is, let's say that once the deployment is done and you want to trigger some Azure functions, or you want to trigger some external API, you can do all that. Or you have some policies, security policies, without that you cannot push your code. You can have the conditions here. In your CD pipeline, so what we do here is number of steps. As a first step, I have a task here which says, okay, go and provision the web app service plan. then I'm installing the extensions, then I'm creating the web app. This is a platform as service, and extracting the test, and I'm using the Python version, and I'm running my functional test and then building it, right? So this is how it looks like. Now, if I go back here on my releases, you can actually see this is being success. Now, if you click on the release, it'll show you what all steps happened and how did the deployment took place. Now here you can see that, okay, this is succeeded. And if you want to see, you can actually see the full log on, on what, how that each step is behaved. You can even click on the succeeded button here. Okay, now this is how it looks like. Yeah, so you see this, all the steps succeed. If something fails, it'll show it is failed, and you can click on that and it'll show you result, like, why something has failed. It's beautiful, the logging, right? Now I showed about Python, right? And another thing is, everyone loves Kubernetes, right? Everyone loves containers. Now I'll show you another thing, how you can actually build use Azure DevOps for your Kubernetes application, right? So what we have here is, we have one Java application which is containerized, okay? And I have my CI pipeline. I'm going to show you a CI pipeline. So this looks similar. There's no difference for any language. So in every CI pipeline, what you see is those tasks. Let me show you here, and there's no difference in for any language. Now here we can see that this is nice, right? I have a first step here, and then I'm telling, okay, go create the container registry, build the image, push an image, and I'll tell you how you're going to hand it, right? Just very simple. Just you click on button here, and then look for what is this? Build. Okay, I'll just say, yeah, Docker. Search. Sorry. Just search for Docker. You see this? You get number of tasks here. Okay, build and push the Docker image. You just click here and say, okay, add, and then that particular the task will be added here, and then from here you can start entering the details. So build an image, push an image, and install the Helm chart and package the Helm chart and copy the ARM. This is CI. Now when I come to CD, so it's again same principle. So the artifact gets created, and in the CI we are not deploying anything here. And when it comes to CD, so we're going to have the similar set of tasks. So one thing what you need to do is Azure DevOps and your cloud, whether it can be Google Cloud or AWS or even Azure, right? You need to establish a connection. So for that, you need to create a service connections, right? In the project settings, you get to do that. And here, when it comes, you can see here, right? Now I have put some Azure CLI tasks, and I'm creating another ARM template to go and create a AKS cluster, and then extract the resources and create your namespace, Kubernetes namespace, and then image, you pull the secrets, and then install the Helm, and then upgrade the Helm. Boom, it's done, right? Now if you go to releases, you can actually see that the release has been done and it is successful. So not only this, right? And what I really like about Azure DevOps is even for Ruby on Rails, and I've just planning to, I was just playing with Ruby on Rails, and then this is containerized Ruby on Rails, and then it works amazing even for Ruby on Rails. And I can show that the pipeline looks kind of similar. Okay, now another important thing, right? One what we also talk about is so these are the, like, kind of the UI way of doing it, right? But we talk about pipeline as code, right? And if you want to treat everything as pipeline, yes, my Azure DevOps supports that as well. The same visually pipeline what you saw, you'll be writing it as a Azure pipeline YAML. This is same like Jenkins file. So what I'm saying here, I'll have to write the YAML script, trigger for any branch. Okay, I want to use this particular Ubuntu agent, and I'm going to reuse this variables. I've created this, and there are a number of steps. Okay, as a first step, this is a .NET application. For .NET, I'm saying, okay, use the .NET version 2, and then run some npm install. Okay, task and display name and input. Similarly, you can add a lot more here. Now, let's say that you find difficult to write here, and what is the beauty here is you click on this particular button here, show assistant. You can actually select this particular thing and just say, add. That will add a code for you. Amazing. This is beautiful. Now, one thing is, this my Azure DevOps supports for multiple clouds and multiple tools. Integration is amazing. And here you can see that I can actually deploy to AWS, like Amazon ECR, AWS S3. You can see this, and not only that, and you can also deploy as well to GCP. Right now, how you do that? And within Azure Cloud, we have something called a marketplace where you can actually search for all the plugins, and you can even write your own. Then you get a lot of plugins. For example, you want to integrate your Slack or Teams, uh, any tool. That there is n number of plugins are available. You just plug in there. For example, Ansible or Terraform, you name it, you have it here. So all the plugins are there. It's just that you select the plugin and install the plugin to your Azure DevOps organization, and it will be available here. Now, one last thing what I want to show here is, so now we just saw that CI/CD is beautifully running and it is executing. Now, for example, I'll just quickly do one change here. If I go to my where is this? Okay, if I go to my code, and let's say this in this Python, and I'm just going to make some changes. I'll show you how this entire the CI/CD runs. Um, the moment I make some changes and I say commit, so what happens here is this is fired D. You can see here it is committed, and I'll go to my releases pipeline. I should be able to see my CI pipeline triggered immediately. So this will take like few minutes. Like it'll do your CI and CD, and within few minutes the changes will be available in your website, in your production website. It's loading. I'll come back to here. Okay, so once we have everything ready, right, and the key thing is we want to visualize what is happening, right? What I really like about this is a dashboard. I've created a simple dashboard here. We can beautifully visualize. For example, a leadership team or somebody wanted to see how many work items we have, who's working on or what is our state. So basically, what they want to know is, are we in a good state to release our your feature? Now you can create a feature, you can create a dashboard here telling, okay, this shows how many tasks are there, how many user stories are there, and there's how many bugs are there, and who's working on what, and what are the state of the bug. And here you can see how many in the continuous integration pipeline, how many have failed and how many passed. And there are some companies, they actually put a big screen and they display this as well. How many commits, and the deployment status. Okay, now if you see here, you see a blue tick mark here. That is, we just committed it, right, and it triggered a build now. But this is a past build happened, 100% successful rate on the test as well. And you can see, you can put other links as well, and you can search for your work items, and it will show the iteration, your sprint, and then what is the capacity of the team, and your release pipeline overview, and how many releases we had, and the pull requests, how many created and who need to approve. Obviously, velocity is important for a team, and a team size, and you can see a build history. So when you have something like this, you can actually click here and say, okay, settings, and configure it, and you select which, how you want to, what you want to display here, and you can show a lot more. And in this particular tab, you can put your custom content. With this, what I want to end here is, Azure DevOps is a very powerful tool that gives you flexibility to, and it makes it easy to get started, and it has a lot of marketplace, and you can actually deploy to anything. And then this gives you end-to-end solution for your end-to-end deployment, end-to-end software development. And if somebody really wanted to learn more about Azure DevOps, and I really encourage you guys take this particular course, AZ 400. This is Azure Developer. I got certified, Azure Developer on AZ 400, and this particular learning path is beautiful. It's amazing. I heard from a lot of people that this is beautiful, and this is going to teach you end to end. It's going to take time, but make sure you spend time to learn on this, right? Amazing. Cool. Thanks a lot. I think I I overshooted like 4 minutes. Thanks, Rohit.
Thanks a lot, Leena and Murugan. That was really awesome, and there are so many code samples and code demos as well. That is what most of the audience looks for. So thank you to both of you. So Leena and Murugan, I think there are a few questions in the comment box. So I'll pop them on the screen so that you can answer to few of them. Works?
Sure. Yeah. Yeah.
So yes.
Where do I see that?
Yeah, it's on the screen.
Okay. Okay. StreamYard. Okay. Okay. So I need to go to live comment, is it?
Yes. No. Actually,
No,
I
Murugan.
have already showed it on screen. So there is a question by Mustafa
Hmm?
is asking, can we integrate with other repos like GitHub repository?
Oh yes. Yes. Yeah. 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 So one example I was showing here, right? This particular pipeline. Which one was that? Okay. This particular pipeline. What do you see here? And if I go to repo, I don't have a repo here. This is actually my code is in GitHub. And you can actually integrate this with your Bitbucket. You can integrate with your other GitLab, and then even other options as well. Yes.
Cool. So I'll show the next question. So the next question is also
So when
by
you click on new
Mustafa.
pipeline, you can actually select it like Bitbucket, GitHub, or GitHub Enterprise, or any other Git, or even SVN as well.
Okay. So the second question is here. Yeah.
Can you read it, Rohit? I don't know where do I find that.
Sorry. You aren't able to see the
Oh yeah,
question.
yeah, I can see on the screen. Okay. How
Okay.
do you share your Azure Git repo with others users and they can do a CI/CD integrations on the same project? Okay, so within this particular project, right, you can actually invite a lot of people. So when you go to this project settings, you can see an option called Teams here. So here, this is where you are actually forming your Scrum team, and you can actually invite people, add people, so that you can actually give a different role for them. Now I have this space game web, right, and I can say, okay, add a new team member, and I can search for a user here and then submit it, and that's how this guy will get added. And you can actually control that particular permission as well. He should be a contributor, he should be a reader, he should be with a different role. You can control that. Yeah.
Cool. So I'm showing the third question. So this would be probably the last question
Hmm.
because we are running a bit out of time. So yeah. So
How easy it is to migrate project from Jenkins Bamboo to Azure DevOps? It's quite easy actually to use it. You could do two options. One is you still run your Jenkins pipeline, you run your CI there, but you can use a CD from Azure DevOps. That's one easiest option to do. You don't want to make complete change. Otherwise, you can even migrate some of your pipelines as well, because it's about YAML, and you convert your Jenkins file into YAML and then create a new pipeline. Shouldn't be a tough job.
awesome. So I think that will be all, Leena and Murugan. Uh, so thanks a lot to both of you for joining us today and sharing your experience and knowledge with the audience. I hope all the participants would have loved it and will be taking something back from it. Also, like guys, if you you could go to the comment box offline and answer few of the questions, because I see there are few more questions. So since we are running short of time, so we'll have to end up this session. So you can go to the comment box and answer them. Sure. Okay.
Okay, thank you, Rohit.
Okay, thank you. Thanks a lot, Rohit. Thanks, Lena. Thanks,
Thank
everybody.
you,
Amazing.
Cloud.
Enjoy
Yeah,
the rest of the day, guys.
yeah,
Yeah,
yeah.
thank you. Bye.
Yeah, enjoy the rest of the day. Thank you. Bye.
Okay, guys. So that was Lena and Murugan. So that was the first session for today. And next we have Aaron Paul from Microsoft. So I'll add him to the screen. Hi, Aaron.
We're online. Excellent.
So Aaron, how are you doing?
Good. Thanks for having me on. I caught the tail end of that session, which is good because I think that I'm going to be able to add something kind of following on from what the folks were talking about with DevOps on the last session. So yeah, I'm excited.
Yeah, we all are excited for this session. So Aaron, going forward, can you give a quick intro about you? What you're doing and from where you are actually attending this session. So from where you're presenting and what your talk is going to be about. Meanwhile, I'll share your screen to the stream.
Yep. Let me just kick off the screen share.
Sure.
And there we go. So I've added that to StreamYard. We'll
live.
minimize this so I don't have, so I can see my speaker notes. And
Yeah.
Excellent. Let's get going. And if I click through, so hello everyone that's watching on YouTube and Twitch, and I've seen at least 2 or 3 other different broadcast mediums that we're presenting today. My name is Aaron Powell. I'm a cloud advocate at Microsoft. I've been doing web development for 15 or so years now, and it's been a lot of it in the front end space, but I've also done a fair bit server side. I started with classic ASP and stuff like that. And today I'm going to be talking a bit about DevOps. So again, it's a good thing that we've just had a really in-depth view of the Azure DevOps product and learn some stuff about there, because I want to kind of follow on a bit more around how we can use some DevOps tools with serverless applications, and also how serverless can fit into DevOps pipelines that we might be building. You can find me online at a bunch of places on social media, on Twitter and my website. And if there's my email address, if you have any questions that you would prefer to ask me over email and all that sort of stuff. But yeah, that's me. That's what we're hopefully going to be covering off today. So shall we get started? I'm going to take that as a yes. This is the challenge with online events, is I actually can't see audience feedback. So I don't know if everyone has just gone to sleep or they're playing with their phones or something like that. But I want to start talking a bit about my journey with the way that I was doing deployments when I first got it started in the industry, and how that sort of shaped the way that I look at the role that DevOps, and in particular the continuous integration and continuous deployment, or the CI/CD aspect of DevOps, how that fits into the applications we build, and in particular the role that it plays in serverless applications that people are building these days. So when I got started, this was how we were doing deployments. We would connect via like an FTP server or a network share or something like that. We would open up the file that we needed to change on the server. We would change it. We would hit save. It would upload, and we'd be done, right? Like, and that's what we were doing. Like, we were quite literally editing in production, because when I got started, it was all scripting languages. It was VB script from classic ASP. It was PHP and stuff like that. So like, the notion of source control wasn't that common in a lot of the companies I worked with early on. So it was very much the sort of the Wild West. But that has obviously some concerns. So we started thinking about how we could do this a little bit more I guess, repeatable to a degree, or at least give us a little bit more confidence. And we would do that by accessing a network share on the production server, or a network share that was available to the production server. We'd copy up a zip file from one of the developers' machines, which was what we were going to hope was the latest release that we were copying up. And like then there'd be folders of full of zip files, which was all the old releases. So at least we could do rollback because, well, we had all the previous releases. And then you would log in via like an FTP or like an RDP session or a BNC or something like that, unpack the zip file, copy the files into the location, and there was your deployment done. Generally just overwriting, and you'd end up with files everywhere that had like .back or like _final _date stamp, and like those were the ones that you knew how to roll back to. But these were generally accompanied by a run book of some sort, like a physical or a digital run book, which was a series of steps that you would go through in, this is the stuff that you have to do. These are the people you have to talk to when you're doing a deployment. Now, this, while I might have made it up for the slides today, it's actually fairly indicative of a lot of the run books that I worked with, like, except for the fact that there was actually a step removed here, step 2, someone removed that, but that was never the case when you were doing run books. They were always, like, no one ever updated them. They were always out of date, and you'd be confused when you're trying to do your first deployment. But I was doing this for years and years, and I never saw this as something that might not have been an optimal way to do deployments. It was like, this is just how we did it. It worked. But there was a lot of stuff could go wrong because this was a very manual process, a very human-driven process. And unfortunately, we as humans are fallible. You edit the wrong file and all of a sudden you've taken the website down, or you upload something to an incorrect location and it doesn't, changes don't get reflected in production. You can't quite determine why that's happened. And like, no matter how good your run book was, how detailed it was, you were never deploying on a Friday afternoon because you did not want to be the person last in the office on Friday night trying to debug why the production server has gone down, because you've just done the latest deployment and you're madly trying to work out where the previous stuff was that you needed. So that's when we started looking at automation, and automation was kind of the next big thing in the way that we did build and release and like deployments of applications. And they generally focused around 3 core phases. You had some sort of action that was going to be triggered by an event. And that was an event that might have been pushed to source control. It might have been hit a button in a web application that was going to trigger off the build, like we saw in the last session, or whatever it might be. Like something triggered an action to happen. And then that action would generate some form of a package, like a zip file or like an artifact drop onto a network share or anything like that. But this was the thing that was your output, where like previously we might have had a run book that said open up VS and compile the application. We were now having that compiled by running a bat file and executing the MS build command instead of actually using Visual Studio, or like a make file to generate our like C++ applications, or running scripts for Ruby or whatever it might have been. But we ended up with this package that was what we needed to release, and then working out some way to deploy this package. It still might have been remote connect onto the machine, but then run a script that would unpack the archive, copy it to a location, repoint the IIS config or the Apache config to where these new files were unpacked to, and now, like, while we still had a somewhat manual process, like we might have had to initiate the original action, we might have had to copy an artifact to a location, or we might have had to log in to run a script to do the deployment. Our runbook was no longer quite as complex of all the steps. You had a lot of that automated because you had a script that you could run that would do some of the tedious copy and pasting of files and things like that. But then we started to have build servers come into play. And these are things like TeamCity or Cruise Control, cruisecontrol.net, and like the various flavors for different languages, Bamboo and Azure DevOps Server. So this is like on-premise stuff. And they tended to be like an old machine that was sitting in the office. Maybe Jane, whose step got crossed out in the run book, she didn't need that machine anymore. So it was now the build server. And it would be the thing that would be sitting there, or maybe we were lucky enough to have a data center where we could like provision this infrastructure, but it was a physical machine somewhere that we had to like manage, and it would do monitoring for that trigger. Maybe it was monitoring our source control, so we pushed to our Mercurial system or our SVN or VSS, no Visual Source Safe, or maybe we're lucky enough to use something a little bit more modern than those tech, and then it would start the compilation step, or running those scripts that we would previously have run manually for us. And but the downside of these was they tended to be built on themselves. So it was, if you needed to do a .NET application, you would have to make sure you had the right version of the .NET framework on there for what you wanted to build. If you're doing Java, the right JDKs on there. And if you were doing multiple different versions of Java projects, and they're all targeting different JDKs, you'd have to have all of them there. And now all of a sudden your build server has got 100 different bits of software installed on it, because each project needs something a little bit different. And then if you needed more build resources because you've got more teams starting up, or you've got more projects that you need to build, well, now you've got to add more of these servers. You've got to hope that either people are upgrading their hardware in the office and you've got more computers lying around, or you can talk to your hosting company and say, well, how can we get some more hardware that we can turn into these build servers, because they were all, it was something that you controlled and maintain, and it was your thing to look after. So what does that mean in the context of serverless? And why have I kind of given this history lesson of what DevOps sort of looks like if I'm talking about serverless, which is obviously a much more modern approach to the way that we can build applications? Well, if we have a look at a couple of different examples on how we can get started. So this is the Azure Functions on the left, and the AWS Lambdas on the right. And this is where you kind of land when you first come to them, and you're like, how do I get started? How do I create my first Lambda? Or how do I create my first function? With Azure Functions, it talks about opening up VS Code, and inside this document, if I did a larger screenshot and you scroll down further, you would use some tooling in VS Code to connect to Azure and then deploy that function directly into a resource in Azure. So essentially, right-click deploy, like we could do from Visual Studio or anything like that. With Lambdas, it talks about opening up the AWS console, that you create some stuff in there, you add some code, and then there's your Lambda deployed. Now, you can do the same with Azure Functions. You can go into the portal and create it and write some code in there. And with Lambdas, you can also use the AWS extensions for VS Code to do a similar thing to Azure Functions. But the problem is that these are very close to that dev in production scenario. Like, my machine is the one that's doing the deployment, whether it's via going into a portal and like literally editing in production, or whether I'm the one that's publishing the code off my machine. And I've got to hope that I've got all the dependencies correct for what I'm going to need in the production environment. I'm running the same version of Node on my machine. I'm not running that I'm trying to deploy to, and things like that. And this makes me come back to a comment from one of my colleagues that friends don't let friends right-click publish. And that's because you really need to think about this automated build and deploy process, because while serverless applications, or at least certain aspects of serverless applications, tend to feel a little scripty, they're things that you're writing to plug together a couple of services and stuff like that. That kind of makes them, well, do they need this full rerun? Like, are we writing tests? Are we writing like this massive deployment pipeline? Do we need to have gates and approval checks, et cetera, et cetera, et cetera? Same as we would with maybe a web application or something we're deploying into Kubernetes. Like, do we really need that? Can I just copy up this script file? Because it's like 100 lines of JavaScript. It'll be fine. Nothing's ever broken with JavaScript on, especially when we're dealing with different types that are coming in from unknown systems. That's always fine. So now, that's enough slides for the moment. I want to jump over and show you how to get started with the tooling that we are generally familiar with. So I'm going to use VS Code and GitHub Actions to set up a pipeline and do that as easily as I possibly can. So if I come over here, I've set up a Git repo that I'm going to start by cloning onto my machine. We're going to make a directory. I will call it ccdays. We'll go git clone. Oops, I copied that in, didn't I? Yep. Oh, no, hang on a sec. I got to git init because I didn't actually initialize the repository. And then we're going to open up VS Code. For a moment, for this to happen, there's nothing like live demos where you're like, how quickly is my editor going to fire up? There we go. And I'm going to start by creating just like the Hello World Azure Functions as you would go by following like the introduction documentation that we've got on MS Docs website. I do have the Azure Functions extension installed in VS Code, but I have another extension installed here that, oops, opened up the wrong folder. Of course I did. That's going to cause me problems in the long run. I better remember that I put a Git repo in the wrong location. And then we will, come on, wait for my machine to realize that I've got to the wrong folder, open up Git init here, open up VS Code. I'm actually using the insiders build of VS Code, but that's just because I like to run with the pre-production stuff and test it for our teams back at Microsoft. But all this stuff that I'm covering off here works in VS Code stable release. And also, while I'm talking specifically about how we do things with Azure Functions and that kind of thing, the patterns that I want to hopefully instill through this talk can be applied to AWS Lambdas or Google Cloud Run, I think is the GCP version, or anything else like that. And again, while I'm going to be using a GitHub Actions for CI/CD, doesn't mean that this stuff is only ever going to work with GitHub Actions. Again, the patterns and practices are applicable to any CI/CD platform that you're working with. Okay, cool. So it looks like we're up and running. I'm going to open up the command palette, and we're going to go to create new project. And I'm just going to start up, like I said, a brand new Azure Functions project in this folder that I've got here. Any minute now, it's going to give me those options. Any minute, there we go. No, I'm just kidding. I know it takes a moment or two. So I'm just going to do a JavaScript one. We're going to set up with, let's just go a HTTP trigger because it's the easiest one to test. Call it HTTP trigger 1 because there's definitely like power defaults when we're setting everything up.
Aaron, sorry to interrupt you for a minute.
Oh, yep. Oh,
yeah. So I would like you to increase your font size.
Okay, cool. I will. Particularly in. I'll make sure the font size in the editor, I think, will be the important one. The terminal, I won't really be using that except for just a Git pull and Git client. Is this font size better for everyone on the stream? I'm going to hope so, because I am not actually able to read the comments at the minute.
Yes, I think they should be fine.
Excellent. Yeah, I remembered to bump my editor, but I forgot to do my terminal. Always remember one, but not the other.
No issues. Carry on, Aaron.
Okay, cool. So yeah, like I said, this is your Hello World function that you can get from Azure, from Azure Functions, and this is done through the Azure Functions extension. Now, I'm just going to add that to the Git repo and then push it up to the one that I have there on GitHub. Any minute now when that terminal wants to run, or no, we'll come back to here. Zoom in. There we go. Boop. That font size should be a bit better. Git add -a. Wants to respond. Assuming it's still working. No, my terminal seems to not be happy. Whoops. Come back to here. What's my machine doing? Oh, here we go. Git add -a. Sure, we'll just ignore that error at the moment. From the terminal, it's just going to be, like I say, git add, git commit, git push. I won't actually be running anything from the terminal. We will go back to just the text editor in VS Code shortly when Git decides that this is going to be an adequate speed to operate at. Git commit -m. And then we want to init, because that's what I'm going to do. And then now I can paste in that initial push up to GitHub. So that's, like I said, this is just scaffold up the most basic of stuff. But what I actually want to do is I want to deploy this to an Azure function that I've already set up. So I've got some infrastructure already provisioned in Azure, and I want to be able to deploy this action to it. Sorry, this function to it. So for that, I'm going to open another extension. So I'll come to the extensions panel. I've already got it installed, but I'll just show it to everyone in here. And it's called deploy to Azure. My machine is performing really subpar today. That I do apologize for, because it is taking like even a long time to actually just search into the extensions gallery. Anyway, this deploy to Azure extension for VS Code does what you would expect it to do. It deploys to Azure. And by doing so, what it sets up is a DevOps pipeline, either using Azure, the Azure DevOps pipelines product, or using GitHub Actions. And we'll detect that based off of what kind of repository you're connected to, or you can actually go in and configure that yourself. So I've got this backed by GitHub, so it's going to detect that, and that way it will automatically configure a GitHub pipeline for a GitHub Actions pipeline. It's going to ask for some information. I need the resource group I want to deploy to inside of Azure, what kind of resource I'm deploying. So this is an Azure function on Node. And then where is it? It's this functions application. Now, the other thing that it's going to need is a personal access token from GitHub, which means that I'm going to share something to everyone on the live stream, and given this is recorded, to everyone watching in the future, an access token to my GitHub. Don't worry, I'm going to be cycling that this token as quickly as I can. Actually, maybe I'll show you where to go to get it. So I've gone to settings in GitHub, and we come down to developer settings, click to personal access tokens, and then we go generate token, and I'm going to need to give it access to the repository. So I will just have to sign into my GitHub again, because it's just, it wants to validate that I am who I say I am before going forward. Give that a minute to authenticate. And where are we? That's, well, there. Oh no, it is going to be able to hopefully face sign me in, or we will just click. One of these is going to work. Live demos where passwords are involved. There we go. So that, that's frustrating in and of itself. Okay, let's just go bang. And I'm going to pop this off screen so that you don't actually get my password, because that would be bad for everyone. Everyone on the chat, talk amongst yourselves. Well, while my GitHub just has an issue. Oh, that's really quite annoying. Okay. I'm going to have to restart my browser because the page has frozen. Very annoying. That didn't happen in my demos, in my practice runs before. So we go github.com. Okay, yep, there we go. My browser has had an issue on the other screen, which is very frustrating because I had a whole bunch of tabs open ready to go. But okay, so we're back into developer settings, personal access tokens, and then we will generate a new token. I will log in a moment. Go to my password manager, tell it to fill that, confirm. Okay, so what we need to do is we need to enable the repo access. So essentially what this personal access token, it allows someone to connect via the GitHub API to talk to, to do stuff with a repository. So in this case, I want to allow it access to the repositories, and we'll see why in a moment. And we'll call that 60 days. And then I come down here and I'm going to click generate token and pop it off screen so I can copy and paste that token without everyone else seeing it. Well, at least for more than a second now. Oh, it looks like I accidentally closed that GitHub project as well in my text editor. So this is going fantastic today. I guarantee this is probably not the most challenges I've had during a presentation. I did have one earlier this year where the power went out in the room that I was presenting in, which resulted in the projector going offline, the lights being turned off, my microphone becoming dead, and I still had about half of the talk to deliver in a completely empty room to a few hundred people. So the fact that I can't actually see anyone and know that you're all like, oh, this talk's going badly, means that I've got a lot more confidence that while it's going badly, no one is that bothered yet. But don't worry, we will get through this together. Okay, we'll just get my VS Code instance restarted. Once everything has loaded up again, we'll start setting up that pipeline. This does mean that I am probably running a little bit behind time. So the second demo that I wanted to do, I'm going to cut a little bit short and show you the end result of it rather than how we could go through and do the whole thing and actually do the implementation step by step, because I don't want to take time from the other speakers that are coming up for the rest of the day. Okay, we're back. We're going to open up the command palette and click the deploy to Azure again. Wait for the extensions to fully load. VS Code does a delay load on the extensions so that while things are starting to pop in, it hasn't fully loaded everything behind the scenes. But now I can start clicking back on those options that I had before. So the resource group inside of Azure that I want to connect to and deploy into, the type of application I'm deploying, it will then use that to determine the applications that are available within inside of where I'm deploying. So that's just coming back. There we go. It's that resource that I had before. We will paste in my, no, it's not an Azure DevOps application. Let's start that again. So here we go. Node, 60 days. There we go. Okay, so I'm going to paste in the personal access token and hit enter and see if anyone is able to freeze frame on that step itself. You've got like a one frame that you might be able to go back and try and get it before I delete this access token anyway. Okay, excellent. That is doing its things, and there we go. So what it's done is it's gone and created a GitHub Actions workflow file. I'm just going to quickly git add and then git commit and then finally push, adding workflow, and then git push. So we'll kick off this in the background before I come back and actually talk about what is happening in this. So behind the scenes, like I said, it set up this workflow file for me, and inside of this workflow file, if you did watch the session before around Azure DevOps and Azure pipelines, you'll see that there's actually a lot of stuff that's fairly similar to it. So we've got a trigger. In this case, it's on instead of trigger. And then it's on a push to what branch? Well, the master branch, or you might have multiple branches that this is listening for, a name for it. And then we have the jobs that are going to be run when this workflow kicks off. So this only has a single job in it called build and deploy. We have what machine it's going to run on. So it's going to run on a Windows Server 2019. You could use Ubuntu or Mac OS, and then you can specify specific versions, or you can just do latest, which will be the latest version for that operating system. So that's another easy way to get started. And then we have the actions that are going to run within inside of that. So the first thing it's going to do is going to check out the code for the Git repo that this action is associated with, so I can get that source code. Is then going to log into Azure. Now, I need some credentials to be able to log into Azure for it to work with those resources that I've selected. And that's what this GitHub action does. It'll perform the login, but we need to provide it the credentials. And that's defined here with this $ double squiggly brackets, secrets.azure_credentials _SHA there. That is a secret variable that was created for me by the extension and added to my Git repo. That was what I need the personal access token for. So I'm going to come back to my repos, and I'm actually going to bring that one up. So if we come to CC days, let me just find it. And so this secret variable is created on my behalf. I haven't had to go and do anything. I don't actually know what that secret would contain, and there's no way for me to actually get to that. So if I come in here and go to settings on the Git repo, and then come down to secrets inside of this, we'll see that there is that secret that's there. Now I could delete it or I could update it, but there's no way to actually retrieve the value of that. So this is where you would put any sort of credentials that you might need to pass into the steps that you're performing with inside of your GitHub Action workflow. Now we'll come back here and we'll just have a look at the rest of it. Now it's going to run some NPM steps because this is a Node project. If it was a Python project, it might run pip. If it's a .NET project, it will run .NET commands. But what it'll do is it'll run npm install, so download all of our packages, npm build, and npm test. This will get me some output artifacts that it then uses with a Azure Functions GitHub action. The name is here is the app name inside of GitHub, inside of Azure that we selected using the extension here, and then where is the location of that file? So that's going to be uploaded. Come back to GitHub, click on Actions. We can see that our workflow is running. Excellent, which is what we'd hoped. I mean, we did do a push. We should have expected it to run. So it's there, it's going. We can come into it. We can see that the jobs that were triggered by that, so the build and deploy job, if we come into this, we can see the steps that were happening. We see that the npm run has completed. We can have a look at the log files from that. It's got no tests, so they're not relevant yet, so it hasn't done any deployments. And then this will it will ultimately deploy to Azure, which is the step that it's currently running. And then we can log into our portal, open up our function, and have a look at what that looks like and what's happened in that deployment. So I'll leave that to go. And instead, I want to have a look at a second demo application that I have and talk about, well, why this can be useful and some of the value that we can get out of doing these, like actually setting up the DevOps pipeline behind it. Demo. This one is data demo. So earlier today, I was going through, sorry, not earlier today, when I was actually writing this talk, I realized that I don't actually have that backup that I was hoping for. Yikes. I was looking at some of our samples around how we can work with Azure Functions to do serverless applications and some of the things that it can do in that space. And we actually have a bunch of examples on the Azure Samples GitHub repo. And I want to go to one of those in particular, which I had previously opened in a new tab on the browser that has the browser window that is now not responding. So we'll come to GitHub in a minute, github.com/Azure Samples, and then serverless data processing. Now, I'll share out these links in the chat after the talk, and I've got a couple of other links that I'll also share if people want to go back and have a look at them. But if we come into, I'm just going to pick this first one, for example. It's going to, this one's called file processing. The way that it works is that if we have a look at the actual function itself, is it's waiting for a file to be uploaded. Let me just zoom that in so that you can read it a little bit better on the live stream. So this has got a file that will be uploaded. It's going to get some configuration out of the function, so that, like the environment variable. It will unpack that file, which is going to contain a whole bunch of lines in it. Each line has a JSON payload in it, so it's going to unpack that JSON payload. It's going to then turn it into a JavaScript object and then pass it over to Cosmos DB to write to. Now, again, this is obviously very specific to Azure sort of stuff, but the concepts are the same regardless of what serverless platform you're working with. You're getting a file in from somewhere, you're processing that file, and you're running it to some sort of a database. But the way that we would deploy this one is it actually talks through how to deploy it using essentially copy and pasting into the portal. So this is the sort of thing that would be really easy to spin up a GitHub Action pipeline to deploy it. Because while you can copy and paste it, it does have some, it's not the desired outcome. And also, once you've done that, you can look at how you could add some basic testing. Like this function here that's actually processing the data that's on each line. Maybe you want to extract that out and write a test. Those are the sorts of things that you can start doing. Whereas this is only, if we have a quick scroll down, it's 59 lines of code to process a file and dump it in. So it's like, well, maybe we can just quickly copy and paste it into a portal or through the dashboard or something like that. But there is definitely value in making sure that we have this automated so that down the track, if someone needs to make a change to it, they don't accidentally copy and paste an old version, or that they get that confidence that you get behind an automated deployment process. But in the essence of time, I'm going to go back to the slides, and we're going to power on forward a little bit into some other things that I want to talk about, which is the role that serverless can play in conjunction to a DevOps process. Now, you might be thinking, well, like, why is that relevant? I'm building serverless applications that are they're running the back end of a web application, or they're doing some data crunching from like our real-time analytics system, or it's doing some monitoring of services and providing out some insights. Well, where could DevOps fit then? So where could serverless fit for DevOps? Well, I actually think serverless is a good model for the way that we can work with our DevOps pipelines. Now, if we think back to what I was talking about originally, like how when build servers started becoming a common thing that people were putting in, they were all physical servers. But now we've moved very much more towards this this server and agent model. With Azure Pipelines, you install agents, and you can have as many of those as you want. You can get them from Microsoft, or you can self-host them. Similar with GitHub Actions. GitHub Actions, everything is run basically as Docker containers or as node commands. So a little node applications, and those are the different steps that you can run. Similarly with Jenkins and Bamboo and TeamCity and all those other continuous integration, continuous delivery tools use this disconnected approach. So they're already targeting a serverless model. You don't have to think about the server and spend hours crafting what needs to be installed. They're already serverless. But also, if you wanted to do something like insights into what's happening in your pipeline, or run something from your pipeline that's outside of what you might be able to write in YAML, or with a custom task or step, serverless is on demand anyway. Like, you don't need to have a constantly running server that's going to be waiting for your DevOps process, so you could have that elsewhere. And something that fits that model nicely is ChatOps. So writing custom Slack commands, like if you're using Slack or whatever your chat platform is of choice internally at your company, it's really easy to write some kind of command extension. This is an article that I wrote on how to do Slack commands on Azure Functions. And then you could have this as like a command that triggers a webhook on GitHub to kick off a workflow. The GitHub workflow that we saw for that GitHub Actions was listening to a push to a particular branch, but it can also listen to a bunch of other things, such as what they call a repository dispatch. That's when a webhook's happened. So that could be how you trigger off a release, rather than, you don't want to push to master branch and all of a sudden you've deployed to production. Well, you trigger a workflow on a webhook, or you might have another webhook that runs the automated tests. Maybe you have a bunch of information you want to understand about your environments. What's been deployed? What were the last 5 deployments? What commits went out in there? What work items were associated with that? So you could write a little serverless function that is going to pull that data together from a number of different systems, so that you can execute that from your chat tool of choice and get that information back. And it's just an on-demand. Like, you don't need a server constantly running, doing nothing for like 23 and a half of the 24 hours in the day. What about the idea of validating infrastructure? With Azure, we have resource manager templates, or RM templates, that we use to define what our infrastructure looks like and deploy. It's a similar thing to like CloudFormation or Terraform and stuff like that. But these templates can be kind of slow to test when they're deployed, because they're often validated at runtime. Basically, what the system will do is it will look at the template that you want to deploy, look at all the resources that are already deployed that are in that target environment, and do a diff of them. And that can be slow, particularly if you've got a large environment. So I read this article. So I'm not going to take claim to this idea. There's an article I read that talks about, well, if you have infrastructure as code, you could create a hash of that file that represents your infrastructure as code, store that somewhere, and then have a serverless function that every time your pipeline runs, it calls the function with the most up-to-date version from source control and says, here's the hash of that file. Does it match the last hash that was given? If it does, well, we're not even going to attempt to update our environment because we know that they're the same. Unless someone has logged in and done stuff just directly through portals or through CLIs, and then you've got other problems because of change management. But the idea of being able to validate that can really reduce the amount of complexity you have with inside of your deployment process, because it just goes, is the upcoming state the same as the last known state? Yes, sweet. We're not going to attempt to change our environment state. And the final one is, what if we wanted to automatically generate release notes for our deployments? So we can look at what work items or issues or pull requests have happened since the last release went out. They've been merged pull requests or issues that have been closed or whatever it might be. We can look at those by knowing when the last release was and looking at that through the APIs, or we just look back in time because we're only doing deployments every Friday or every Monday morning or whatever it might be, and pull those out. And then generate a markdown file that we can push out as part of our release, or a text document, or whatever it might be, and include that in the outbound artifacts. Now, this could be really useful if you're creating libraries that you're publishing onto whether it's NuGet or NPM. And I've created a link here if I can get it to load up. So I'll click on that. There we go. And this is a article, if I can find which browser that went to. There it goes. So this is an article about how to do that with Azure DevOps. So this is not for GitHub Actions. This is for Azure DevOps, which was covered off in the previous session. And it's got a code walkthrough on how you do that. And you basically plug it in as an additional step for your workflow. You just call this, it generates the file, and then you save it back down because it comes back as a response. You save that to the artifact location that you're publishing out with your release. And that's, again, this is not something that needs to be constantly running and constantly available. You just need to run it on demand. So just to wrap up, serverless deployments, you want to treat them like any other part of your application stack. And whether it's a web application or like a Kubernetes cluster, just because it's only 50 lines of code doesn't mean that you shouldn't have repeatable deployments behind it. You shouldn't be able to add testing without it being done on a developer's machine or anything like that. And with things like the Deploy to Azure extension in VS Code, it's really easy to scaffold up that workflow initially and get it started for you. VS Code, like I said, it's super powerful to be able to do this, whether it's GitHub Actions or Azure DevOps. To get started, quite easy and simple to fire it all off. But also consider what role serverless could play to give you better insights into a DevOps pipeline. Whether that is something in Slack so that you can pull back some information about what's happening in your current environment and like what's deployed or whatnot. Or maybe it is you want to be able to generate release notes that you can publish out as part of a release package so that someone down the track can look back and go, well, what was included in this deployment? There we go. There's a set of release notes that we have for us. Thank you for listening in today. My name's Aaron Powell. Again, here is where you can find me online. And I'll jump back and see if there are any questions. Again, I do apologize for the fact that the demos didn't work as smoothly as I was hoping for, but I'll share out some of those links in the chat. And I'll also, they're also going to be available on, there's a GitHub repo with all the slide decks. So I'll make sure that I update that with the relevant information as well. But thanks for dialing in. I hope that you've learned something. I hope it was enjoyable, and I hope you enjoy the rest of the day.
Yeah, thank you, Aaron. So I think the session was an awesome session. And yeah, looking at questions, let me just quickly go through these. So I'll be flashing the questions onto your screen. So
Yep. I caught the end of the last session, so I saw how they're going to pop up. So I'll get a chance to. I got a preview of how it's going to flow.
That's awesome. So let me just quickly go ahead and show you a question.
there's a question: is the GitHub apps that uses OAuth or PAT? So the extension that I showed off today uses the personal access token, or the PAT. The reason for that is so you don't have to authenticate the whole VS Code into accessing the repo. Now you can actually be more fine grained on the permissions that are required, or the permissions you give to that PAT before you paste it into GitHub. I was just being kind of quick and lazy, and it's like I'll just put in the whole repo, but it really only needs to be able to update settings, and I forget which explicit sub scope of repo it needs, but you can just really fine grain the access of that if that's more preferable. But yeah, it's designed around using access tokens rather than OAuth.
Great. So apart from that, we don't seem to have any questions. So Aaron, I just request you to go back after the session ends, to go back to the YouTube comment section, and if there are any questions, so you could probably answer them like that.
Cool. Thanks for having me on. I hope everyone enjoyed. Everyone learned a bit, and they also saw how to have demos fail when you're presenting live on screen, because that's always a fun experience to have.
Yes. So yeah. So once again, thank you, Aaron, and thank you for being a part of Cloud Community Days. It was great, exciting, hosting you.
Cool. No worries. See you, everyone.
Yeah, and thank you so much. So next up, we have a session from Mamta. She'll be talking on building, deploying, and managing microservices-based applications with Azure Pipeline and AKS. So let me just quickly go ahead and add it. Hey, Mamta. Hello, Mamta. Can you hear me?
Yeah, I can. Hello.
Hi, Mamta. So how are you?
Yeah, I'm doing good. Thank you.
Great. So really excited having you as the speaker for Cloud Community Days.
Same.
It would be great if you could go ahead, introduce yourself, and just give a brief. Yes.
Yeah. Just let me know when you guys can see my screen. Yep. Okay, then hi, good morning, everyone. Hoping everyone is having a great sessions from last 2 days. And yeah, today I attended Murugan sessions and then Aaron sessions. It's all more of Azure DevOps, I felt, and that's because Azure DevOps is pretty famous. So I'm also trying to cover a bit of Azure DevOps and trying to show a deployment in AKS, which is Azure Kubernetes Service. So let me start with my introduction first. My name is Mamta. I have founded a company recently in the month of Jan called as Tech Scalable. We work on cloud technologies, doing consulting and training. So I come with around 14 plus years of IT experience, and I'm certified in all the public clouds, and my passion is DevOps and Kubernetes these days. So I love doing a lot of things on Kubernetes. That's the reason we would be talking about a lot of Kubernetes and DevOps today. Hope you people like the session. So let's start with it. So today we would be talking about microservices-based architectural applications, which can be deployed using Azure DevOps to AKS. And these are two of the basic tools which are being provided by any of the cloud providers. But end of the session, we would see why Azure DevOps is pretty famous and what are the benefits of having Azure DevOps. So let's start with the session. Today's agenda would be, we would have our AKS cluster up. We would be setting up a 2-node cluster. We would have a private container registry, which is Azure's private container registry. And in that, we would be pushing the images, which we do build by using the Docker. And we would be setting up our Azure SQL Server. So here I want to show how an application, when it gets distributed across AKS plus a backend SQL database as well. And your Kubernetes seamlessly talks to any type of backend databases, whether it is running in Azure Kubernetes service, or it is running as any other managed service as well. We would be discussing how to have that Azure repos to do our control for the code version controlling. And we would be using Azure Pipeline for continuous integration and build. I saw in Murugan sessions and Aaron session, we have covered a bit of it. So I'll just quickly run through that and try to focus more on AKS in this session. With the Azure Pipeline, which is the release pipeline, we would deploy the code to AKS. And let's first understand how we would be building our infrastructure. A lot of ways are there to build the infrastructure. We can build it in an automated fashion as well. But here I wanted to show the ease with which you can deploy using your Azure command line. So with AZ command line, we can deploy using this. So I'll just try and break this because I've already bought up the infrastructure because it would take some amount of time. So I have already deployed, but I'll just explain you the command so that when you go back and try doing it, you understand what parameter needs to be passed at what point in time. So to deploy a AKS cluster, you say AZ, which is for the Azure command line tool. AKS is the resource name and action is the create. You say it as verb or action, and you're specifying in which resource group you want to create this particular resource, what would be the name of the resource, and you're enabling some add-on things. You can have a dashboard, you can have monitoring and build, and a lot of other stuffs as well. You can use multiple other features provided by Azure itself to club along with AKS and work together. You can provide which version of Kubernetes you can want to go with, and you're generating an SSH keys so that those keys would be used for setting up your credentials for the cluster. And you specify the region in which you would like to spin up your cluster. So I have spin up my cluster in Southeast Asia region, and I've given a unique name called as K8s demo. Let me quickly show you that. So this is my Azure portal. Hope so the font size is good. And this is the Kubernetes service which I have bought up. And let me take you through this. So in this, if you see, there are a lot of things. If you want to do a lot of stuffs like upgrading, scaling, and all that, you can do it from here itself. I had started with a 1-node cluster, and now I've gone to 2-node. It's pretty easy. You can click on this, you can say scale, and that would scale up. You just need to scroll this bar, and you can see how many nodes in the cluster you need. And you can just say apply. Obviously, that will take amount of time because when it is bringing up a new virtual machine at the backend, it is installing the Kubernetes worker nodes, kubelet, Docker, and all that stuff, and making it ready for joining in inside the cluster with the master and the 2 worker nodes we already have. So we can go and check in the command line as well. So I'll quickly go to the command line. At this point in time, you will see just 2 nodes, but we would come back to this and we would do kubectl get nodes, and we would find in some time we would have the 3rd node up. So if you see, kubectl is the command line tool to talk to Kubernetes cluster. Once you have set your AZ command line tool, you can just set the subscription in which you have bought up this cluster, and you can right away go and fire these commands after that. So kubectl is the command line tool, get is the verb or the action I want to perform. And after that, it's all the resource type. I want to get how many nodes are there. So I'm just listing the nodes over here. And I've picked up version 1.15. The next set of resource which we would be creating would be the Azure Container Service registry. So in that, we would say Azure ACR create, which is the Azure Container Registry create. We are specifying the resource group in which you want to create. You're giving a unique name for your container registry, and you're specifying the location. So with that, your Azure Container Registry will come up. Let me quickly take you to my Azure Container Registry. In case you didn't find it here, because I have recently used, you would find it here. It's pretty easy. You can type in few words like container, and you would find few, in the beginning itself, it would be there in the first group of options in the drop down. So this is the container registry. And as everyone knows, we have registries for saving our code. Same way we have registries for uploading our Docker images or any type of container images, wherein we can push those, and it works very similar to tools like Git or Bitbucket, where it uploads the Delta, downloads the Delta type. So here, if you see, I have the repository section. So registry is the place like a server. I'm getting a space in Azure, and I'm saying that that is my name for that particular registry. So I would get a unique name there. You have to create a unique name. And repository is the package. And in that package, I can have several versions. So since morning, I tried just testing, because as we saw a few times, demo don't work as expected. So I was a bit cautious and I was trying it continuously. I've tried pushing so many versions of the image, and the latest one is always tagged latest. It's as soon as we push the image, it would be tagged as latest. So this is the Azure Container Registry, and I would like to show the unique name which we have, and this is the unique name of the server. So this is the server to which you would be pushing your Docker containers image. So let's go back and then see what else we have to spin. Because my Azure Kubernetes service got to push or pull images. In this case, we would be pulling the image from Azure Container Registry. AKS has to have authority for that, and that is the reason we are assigning a role to it, and we are creating an assignee. We are saying that AKS is the assignee, and we are assigning a role of ACR pull, which is Azure Container Registry pull, and we are saying the scope is ACR. So this is also on the Azure level. I am just creating service principal. So how we have users authenticating via keys or passwords, same way when services communicate, they communicate via something called a service principal. And those who would be from the Kubernetes world, it's called as service account. So this is for inter-service communication. So you're authorizing AKS to pull image from ACR at this point in time. So once that is done, because we are deploying our backend database in SQL, so from this short and sweet set of commands, I can create the server and I can create the database as well. So let's break that and let's see what we are exactly executing. SQL server create, very simple. The region in which you want to create, the group, or the resource group mentioned, the name for the server, the user and the password, the admin user password, you can give it over here. Sorry for that. And this is the db create command, using which in this particular server, which you have created in the above command, you would be creating a database. And here you specify the database name. So once these infrastructures are up, let's see who gets up this infrastructure. So in our office environment or in our project environment, we would have a person who would be having the access to the Azure account, would spin up our Azure cluster for AKS cluster for us of Kubernetes, would spin up the SQL server, would create the container registry, and then he or she, or maybe some other person not from the infra team, would set up the repository from where people can push the code to, and then we would have the pipeline created. There should be two set of pipelines. So pipeline word is a bit confusing. It does pipeline does the build, and pipelines release part does the release. So you have the build pipeline, and then you would be having the release pipeline. So this part is the infra part and bringing up the complete Git, or like how we have a Git synonym for Azure DevOps, we have something called as Azure Repos that is there, and the pipeline setup. So we saw the ACR, the SQL Server, and the AKS. We have not seen the Git. So let me take you quickly to my Azure DevOps portal. And this is the place. I've created a project over here. It's pretty simple to create a project. You would have an organization over here, and you can create several projects. I've created a project. You can see there's a quick button over here. You can add and create projects, and you can push your code to that. So like in Murugan's case, in his demo, the code was residing in Git, but I'm using Azure Repos, and this is the place where my code is residing. So this is the repos part, And this is the pipeline part in which I have built up my build pipeline and the release pipeline both in place. And I've done the deployment as well, but I'll quickly run through the code file. When we are saying we are deploying it, we have the code with which we have to prepare the image. That would be the first section. And second, there should be a set of instructions using which the Azure Kubernetes service would go ahead and deploy this code as a container in Azure Kubernetes cluster. So for building up the images, as usual, we have the Docker Compose file. We would do the build command and we'll prepare the image. And these things would be done in the pipeline section. And this would be the file which would be used by the build pipeline. Once the code is built, so code build remains the same, right? The way the code is built, depending on what type of language you have picked up, you would be picking that type of build operations. Plus, for the building of image out of the code, you are using the Docker Compose file. And let me take you quickly to the build pipeline so that we understand what exactly we are doing in it. I have tried to keep a lot of environment variables as not static. So I've kept the SQL server's ID as a variable. I've kept Docker container images as a variable. So I've kept a lot of things which are as a variable, and I'll show you how you can define variables over here. So here you can see a set of tasks defined. A lot of options are given over here, and there are a set of actions which these tasks would be doing. And in the last few sessions, you saw that in case we want any of the servers to build an image. Like, for example, if I am not using Azure DevOps and I want to build a Docker image, I would need a machine with which I can do the build and I can create a Docker image out of it, right? So I should have a machine on which I would deploy Docker, plus I should have a machine on which I can do my build for my code as well. So here we would be taking resources, that means the servers from Microsoft hosted agent. And it's pretty easy, as in when you need the machine, you just request for it. And if it is granted, you have it. So let's focus on these services, these tasks, the run service, the build, and the push. So run service prepares a suitable environment for pulling required images, such as we are using ASP.NET Core things. So it would be picking that base image, it would be restoring packages, all those things is being set in this particular task. Then you have the build section where you would be building the Docker image. So this is the place where it picks up the Docker file, Docker Compose file, which I had shown you few minutes back. And using this, it's saying that this is my registry location and this is the subscription. So you come from top to down. Here it's a container registry type. This is the subscription, and then this is the container registry to which you would be pushing the image, and you would be building image using this Docker Compose file. And
hey Mamta, can I interrupt for a second?
Yep.
Yeah, so a lot of people are saying that the font is not, clearly visible. So would you mind increasing your screen size?
Does it look fine
great.
now? Okay.
Yep, this is great. Yeah, carry on.
Yeah, sorry for that. In case you guys have missed anything, I was just covering the run section in which I showed that you can specify what would be the type. I'm saying I would be using a container registry, which is Azure Container Registry. And once you choose the proper subscription, you should need to have a service connection built up in the project setting for this. And once you have connection with your subscription, this would come in a drop down itself. So you can see this is the registry and this is the compose file with which you would be building your image. So a few things you are setting up in the environment variable, then you are building, and then the final one is the push. In this, you would be pushing where to push, it's being sent, and it says what would be the environment variable. And when you're building, how would you tag? You are tagging the images over here, and you're saying include latest tag. So each time I build, it gets a number. You would have seen in my Azure Container Registry, it was showing up. There are few numbers in the repository. So if you quickly go here, I would like to show you that there were a set of image versions which was being uploaded, and it keeps on increasing. But to pull that, it is much more easier to pull with the name latest. That's the reason we are retaining a tag called latest over here, so that people can pull it in the AKS too quick. So then we are doing publishing and all that stuff over here. You are publishing the artifacts. So here you would publish two stuffs. You are publishing the main artifact of the code, plus you would be copying a set of files. And this is the place where you're saying this also would be the part of the package, because this also has to go along with the code, and then only AKS cluster can pick this and spin up your resources in AKS cluster. So let's quickly go back to our repository and see this particular file and what is the content and what we intend to deploy in our AKS cluster. Hope the font is fine. This is the version in which this kind was introduced, the deployment kind. So Azure or any Kubernetes, these are standard Kubernetes stuffs, right? Once your Kubernetes cluster is up, whether it's in AWS, Azure, on-prem, name any cloud provider, once the cluster is up, you can run with all kubectl commands, and you can manage the cluster as the way it works in any other cloud provider. So it's pretty simple. So this is a kind of resource we are trying to create. And what exactly is a deployment? Deployment is a type of resource which helps us manage replicas of an application. So I can do auto-hailing, auto-scaling, and all that stuff with the help of deployment. In case deployment is a controller which would help us maintain desired number of replicas at any point in time. So if I say I want to run one replica of this, my MHC back is the name of the application. And here, if you see, it is just labeling those resources so that it can be worked on the Kubernetes cluster. And from here, the pod section starts. So this is the label for the pod. And in the spec section, it is the container. And inside that, you are just pulling Redis image. And this is the container port. This image, I'm not pulling from the container registry. I'm just pulling this image from a open source registry like hub.docker.com. Okay. And in Kubernetes, as in when you're deploying an application, because it's getting spinned as a container and container don't have a persistent IP address, we would be wrapping it up with one more component called a service. And this is not a process that it will get killed and it will lose its IP address. Rather, it's like an entry, and it would retain itself till the time you go ahead and delete it. So here, services can be of several types. You can expose your application only within the cluster. And because this is a backend type of application and you just want to have it within the cluster exposure, that's the reason you have mentioned the type as cluster IP. So with this, what would happen? Kubernetes would expose this application only within the cluster, and you can't reach this application outside the cluster. You can specify the port number with which you want to get in connect with this application. And this is the selector for any of the labels. So because in the world of containers, you can't retain the IP addresses, labels and selectors play a very important role. You can identify an application, or you can identify any sort of resources, I would say, with the help of labels. Okay. And whenever you want to select a particular label, you say the selector part. So let's see, we would be deploying two applications, the front end and the back end. That was the back end part. And this is the front end controller, monitoring the application which is being deployed. And it will make sure that every point in time, I have one replica running. And here, if you see, there are a few types in which you can roll out. You have canary type of deployment, you have deployment rolling out as blue-green deployment. You can do a lot of things with the help of the resource type deployment. Okay, let's go to the section of pod and the container with which we are more interested at this point in time. So this is the label for pod, and this is the spec section in which I'm defining my container. And this is the name of the container and image I'm giving where to pull from. And I'm saying always pull the latest image. So what would happen in ACR, even the last build was 97, that particular image is tagged with two different numbers. One is the 97 and one is latest. Even though image is one, it has two separate names, you can say, like how you have a good name and a name with which you are addressed at home. It's like that. So if you want to not change this number every now and then with the build number, you can write it as latest, and in your push time, you can say that include the tag of latest. Okay, and this particular container would be exposing port number 80. These are a few of the resource constraints which we have defined, how much of resource we would need. And this particular service, which is being used to expose the front-end type of application, because it is front-end application, and I would be exposing this outside the cluster, I'm going with a service type called as load balancer. And this is very beautiful in case of cloud and all. When we say type load balancer, AKS takes the responsibility to talk to any of the cloud providers, or the Kubernetes service takes the responsibility. In our case, AKS will talk to our Azure cloud account and spin up a load balancer in Azure. And that particular load balancer would be helping us load balance across the number of replicas which would be there. Okay, so this is type load balancer, and this is the port number. So let's quickly go back and see the release pipeline. I showed you up the build pipeline, and I will show you the release pipeline. You can click on edit anytime, and you can see the build and the release pipeline. So this is the part I'm saying here is the Artifactory, and where's the Artifactory? Once the build was done for the build pipeline, you can pour in, and it is there in the pipeline itself. And this particular thing, as soon as you trigger, you can see here, you can say enable and disable. I want to build every time there is a change, and that is the reason I have here marked it as continuous, or you can even schedule any particular scheduling can be done, build every day at 6 p.m., build every weekend and Friday 6 p.m. types, anything like that. And these are the set of jobs and tasks which we have. Because we got to deploy two things here, our backend would be deployed, our database contents would be pushed to the Azure SQL. So there is a DB deployment happening. And then we have the complete set using which we would be deploying two container services, which would be running in Kubernetes. So here, if you see, we would be deploying that in AKS, and this is that deployment section. So this is the normal DB deployment which we have. And in case of this as well, we are using a set of Microsoft hosted agents so that we can trigger that deployment. And here also we have an agent with which we would be communicating to our AKS cluster, because Azure DevOps is there on the cloud, right? I don't have a machine from which I can run a kubectl command, or I can really push or trigger a deployment. So we pick up our Ubuntu machine, and then we go ahead and trigger this deployment. So this is also pretty same. You are just using your service connection. You are saying which subscription. And because you are deploying this to your AKS cluster here, instead of giving the ACR, that time we were intending to pull or push the images to our container registry. So in this case, we are using this resource group. Inside this resource group, we have a cluster, and there is where we are pushing. And in Kubernetes, apply is the command in case there is a Delta change that would get updated. In case you're doing a fresh deployment with kubectl apply as well, you can apply that deployment for the first time. In case there are no resources, it would create them. And in case there are existing resources, whatever Delta is there, that would get applied. So this is the path it would be picking up. We had seen this file just now, the mhc-aks.yaml, which had the deployment and the service definition. And this is the place it says where to pick the image from. So with this, if you trigger the build, I know the build will take a bit of time. Let me trigger the build still, so that in case it finishes, we can know that the build has finished. So this is my build pipeline. I'm just running the build pipeline. And because I have automated the build and the deployment, I can do the deployment in an automated fashion. You can quickly go here and check for the updates. In case your build has started, it has grabbed a Microsoft hosted agent, it will start doing the set of action. It is starting the first phase and it is initializing, it is checking out the stuffs, and slowly it will run one of all the tasks and jobs which you had specified in your build pipeline. Same way, once the build pipeline is done, it has pushed the image to your ACR, it would trigger the the release pipeline. Okay, so let me quickly take you to my cluster, and to talk to the cluster, I'm using my terminal of my Mac laptop itself, and from here you can do kubectl get all. This will give me all the resources which are running at this point in time in my Kubernetes cluster. And if you see, I have two things running. These are the nodes, and these are the pods which are running. One is the front-end pod and one is the back-end pod. And I have two services, one of type cluster IP, the other type load balancer. This IP address is not resolvable outside, only within the cluster you can resolve it, and it doesn't have an external IP associated with this. And for the load balancer type, you get an IP address, and with this you can reach the application. And if you see, this deployment already says how much is ready, how many is expected, and all that stuff, right? Instead of getting that deployed, because that will take a bit of time, I'll show you how you can scale from here itself. We want to scale our number of replicas in the deployment. So you can give the name of the deployment which you want to scale, like the name of the deployment is this, and you can give -- replicas, and you can say equals to 5, for example. What would happen? It would quickly spin up 5 new containers wrapped up with a pod for you so that Kubernetes can manage. Let me show you the pods. You can do kubectl get pods to list the pods in the cluster, and you can see already 2 are in running state. We were running with 1 and I scaled to 5. So 3 of them are in running state and 2 have just started creating. And if you want to do a watch on this command, you can do with -w. And there is an error. Few of the images are proper and few of the images are not reflecting correctly. We can debug that, but that would be an image issue, I think. I can quickly show you where are these pods placed with -o white command, and you can quickly go and check, and you would see normally it gets distributed. Our third node is also in action. It's 0, 2, and 3, the node numbers, and it is almost equally distributed across them. And there are a few errors in this. We can obviously go and check back what is the issue. So how do? You can do a kubectl get events. Normally, we don't expect this to happen in real-time live demos, but you can't help. There is some issue with that, and it's giving an error. So let's go for it, and let's look why it has failed. It says object has been modified, and it doesn't have the latest version. I think we have run the build and those things parallelly, and we are doing the deployment as well. So that's the reason few of the things have worked fine and few things have not. So let's see this kubectl get pods. I'll quickly scale down as well. And this is the way in which I'm scaling up or scaling down. And that's a manual scaling, right? You can say, Mamta, what's the fun about this? If someone has to really run a command and scale it, how helpful it is. Agreed, it's not that helpful, but in case you want to have that also in place, there is a component or a type of resource in Kubernetes called as horizontal pod autoscaler, and you can implement that and make the deployment much more intelligent to scale depending on the CPU or the memory resources. So this was the demo part which I wanted to show. So here we have done. We have checked in a piece of code, and that went to the repository, and repository triggered the build pipeline, and Docker image was created, and Docker image was pushed in my Azure Container Registry. And then we triggered a release pipeline with the new set of artifacts and the images, and we pushed that, and this was the container in continuous integration phase. And once we are having the package build, the artifact and the Docker images, you can go ahead and deploy the newer version of your SQL database, and you can also trigger your AKS deployment with the new set of AKS file which you have. And once that is done, the AKS, which is the master node, which we don't own in case of the managed services, goes ahead and pull the latest set of image. And then after it has that image, you can go ahead and create the pod. So this would be completely automated, right? The pods have automatically come up. We have not done anything to it. And we have also created a load balancer, which is there in our Azure account, but it is not residing in the cluster. It's an external load balancer, which we have created. Once we have done this, this is the CD part, and this works awesome. The CI and CD is done. So let's quickly remove that and think of the data plane part of it. If a set of users want to reach my web server, they would be routed to the load balancer using the DNS name, and that would get routed to the front-end application container. And in case my front-end application container wants to talk to the back-end application and it wants to talk to the database, all those things are pretty stitched up at this point in time, and we can see our database is serving and our website is up. So quickly, let me pick up the service IP address. So you can do a get service, and this was list all the services, and this is the IP address with which I can reach. So let me quickly go to the page and here see whether I can reach. And this is the one which I had opened. If you see, this is the same IP address. This would take a time to load. Yeah, it's up and running. So this is the website we are hosting using our AKS cluster. This is running in container with 3-tier type of application, the front end, Redis, and the SQL backend as well. So this is what I had plans to show as a demo. In case there are any questions, I would love to pick that. Let me quickly switch to my StreamYard thing. Hope I'm on time. I was not actually taking a note how much time I've taken.
So yeah, Mamta, this was a great session, and we've got a bunch of questions in the comment section. So what I'll be doing is I'll be flashing them on the screen so that you can answer them directly. So we have a question from Avinash Emma.
Yeah, you can do that. There is an on-prem version of it, which is called as Metal Load Balancer. And you can use Metal Load Balancer. But in case of any of the cloud providers, how it is a software-based load balancer, right? And it is running on a server which we don't know about. So in case we are having a Metal Load Balancer, you would be having a server which would be having software in it, and it would be working as a load balancer, and you would have to fix that IP address as the IP address for your service. You would have to do few things manually in that case. But yes, it can certainly be done.
Awesome. So we have one more question from Suman.
Yep. Okay, so inbuilt monitoring using Azure Monitor, you can always monitor any type of resource you're running on Azure. You can do that. In case you don't want to use that, the inbuilt one, it's not like something comes as inbuilt. You could see, I would, let me check here. You can check with Azure kubectl command, kubectl get all-n and kube system namespace, and you can see all the system resources. Because we are not having the master with us, still then you can list the set of resources which are running with the master. You have a metrics server for collecting metrics and all, and in case you see over here, dashboard is also installed over here, but you don't have any monitoring services. So logging and monitoring, if you want to do, you can use Azure service itself, or you can go ahead and deploy Prometheus, ELK, AFK stack, any sort of application which can be deployed in containers, you can use them. Let it be Percona, let it be Elasticsearch, Fluentd, Kibana, Grafana, all those, including the dashboard and whatever type of application we normally use for virtual machines, everything makes sense here as well. But they would be running in containers. Hope
Awesome.
that answered his question.
I hope so too. So, let's take the last question for the session.
Yeah, sure. So log service is the one in which you are just logging few of the things, the tasks, so that few of the changes which are happening that would not reflect. For example, if I am upgrading any application, normally we do a hold on sub packages so that they don't get automatically upgraded. So for that section, you are just making sure that few things don't get deleted. So you are just locking those services. So you can lock those services. You would have heard of something called as Azure Lock. With that, you can lock some services, and people can only do a read only. They can't go ahead and make changes to that. So in that section, we were doing that sort of stuff.
Yes, Mamta. So I hope that answered your question, Kalyan. Once again, it was awesome having you on Cloud Community Days as a speaker. I'm pretty sure everybody watching the session, thoroughly enjoyed it, and we keep getting an influx of questions. So it would be great if you could, take the questions offline. Yeah, Mamta, thank you for being on Cloud Community Days. It was great having you.
Thank you. Thanks for having me. Hope you guys like the sessions. Catch you sometime later. Thank you. Bye.
Sure, Mamta. So next up, we have Niharika Krishnan. She'll be speaking on the following topic. Let me just quickly go ahead and add her.
Hello.
Hey, Niharika.
Hi, Akshay. Am I audible?
Yes, you're all clear. So, yes, so it's great having you on Cloud Community Days.
Thank you.
So, if you could go ahead and give a brief introduction about yourself and your topic.
Okay, yeah. So, I'll be talking about diving into the world of spell checks. I could probably start sharing my screen, and then give a brief about myself. Is that all right?
Yeah, sure, Niharika. Please go ahead.
Okay. Is my screen visible?
Yes, Niharika.
Okay, great. So with that, hello everybody. I'll be diving into the world of spell checks. So this falls under the natural language processing aspect of the talk. And so before we get started, let's a little bit about me. So I am currently working as a machine learning engineer at TCS. So I predominantly build intelligent chatbots using open source natural language processing tools. When not at work, I contribute to running the PyLadies Chennai community and talks at other conferences. And I think with that, we can get started. So this is a pre-COVID era. Okay, this is a statistics which we have seen. Probably everybody in the year of 2019 have sent almost about 269 billion emails in that year, and which approximately is like 20 mails in a day. But you can kind of imagine in post-COVID area, this number will be pretty high. So what would you react, or how would you react when you have such a situation, right? So a spell check is very trivial if you think in the complete NLP pipeline, but very important when you look at it from the point of view that you make a mistake and you really hoped like hell that you can get that mail back and you can do an undo function, right? So just to give a brief of the various applications where spell checkers are used is basically you have your search. All of us make spelling mistakes when we have searches, and we have queries where they say search instead for this. So that is when we are so thankful that okay, the machine behind understands that we have made a spelling mistake, but is smart enough to recognize that and then provide a correct suggestion. So that is one where we use spell checks, and then we all use WhatsApp on a daily basis or send text messages. So at every instance, you have predictions, you have spell checks. So for example, here I tried to misspell the word conference, but then the keypad here can suggest that these are the probable words which you're trying to say, right? Or you are using your Microsoft Word or a doc where you're typing something and you see those small red lines beneath, and so that is where you can see a different types of suggestions which come out, and you choose. So when you're trying to send out a mail or trying to send a letter or an important document, you are thankful that you have this functionality inbuilt in your application. And the last is, especially when you're trying to talk to a chatbot, be it using text or be it using speech, you don't want the chatbot to give you a wrong answer or just because you made one small spelling mistake, right? You want the chatbot to understand what you're trying to say, and even though you've made the mistake, give you valid answers. So this is basically what I'm trying to show is the outreach of or the kind of impact a small spell checker functionality has, and it is a very important process in the whole text pre-processing part of the NLP pipeline. So I'm sure yesterday's session, the whole NLP pipeline would have been covered, but this is something where this needs to be modified based on your use case. It needs to be used. Let's say you have an industrial applications which do not have the standard dictionary words, but you still want want this functionality to be there, right? So spell check is one such functionality where you can tweak it, although it can be imported using just one line, which is what we'll be seeing in the upcoming slides. But you need to understand the various algorithms behind. You need to understand in which situation which algorithm to use and how you can tweak them for your particular domain specific use case. So that is, with this in mind, we dive right into the kind of packages. So Python has a package for everything, right? It makes your life very easy. So NLTK, TextClaw, PySpellChecker are some of the very famous text pre-processing or NLP tools which are there. And like you can see, like I mentioned, you just have to import it and it's one line. Okay, let's say you want to correct your spelling using TextClaw. All you need to do is b.correct and you have the spelling. Or for example, you want to use spell checker and then you want to get the candidates, and you give a wrong example, for example, computer, the computer still understands and it gives back the right word. But there's a lot of algorithm which runs behind, and how is it that when you have kaput and kaputs and compute, how is it that the computer is able to give back one answer, which is computer, right? So we will dive deep into the kind of algorithms which are running behind and what really happens under the hood. So in a nutshell, if you see, that is the kind of flow of how a spell checker works, and what are the different types. So a spell checker, like you saw, it basically corrects the spelling and it gives back the probable suggestions. Whereas an autocorrector is something where you just get the best out of the alternatives and then it automatically corrects it. So it's 100% sure version of a spell checker. But underneath, you have three different main types which you need to focus on. So one is phonetics, second is edit distance, and the third is symmetric delete spelling correction, right? Phonetics is something where you work on the syllables, or basically on how they sound. So when you have homophones, when you have two words which are similar to, when you have names which have Smith and you have a name which is Schmidt. So both of them sound very similar, but the only thing different is how the spelling of it, right? So these are the things where you capture phonetics, and edit distance, which we will talk about, is basically on the string length and how dissimilar they are from between two strings. And symmetric delete spelling correction is by far probably one of the most widely used and one of the better alternatives of spell checker. So the main thing with spell check is when you have real word, when you have dictionary words, and you create an error in that, it's very easy to find it out and correct. But when you have words which are not dictionary words, when you have names, so that's when I think phonetics helps you do a better response. So you can see a very similar example here when you have break and break. Both of them have the same sound, but they have a different spelling, and they're used in different contexts, right? So we have two main algorithms, which is like SoundX and Metaphone. So from a Python point of view, from a user point of view, it's just one line. You import a package which is jellyfish, and then you call the SoundX function, and then you give the string. But what you can see in that is the response which you get is B620, and B620 is both of them are same. So when you have words which are similar sounding but different spellings, the key which is generated here remains the same. We also have another algorithm which is called as Metaphone, so which also gives back. It runs on a different set of rules and it's a different set of logic, but both of them give the same thing. So for a user point of view, you are able to distinguish, or you're able to understand that both of them are from the same are homophones, and then the user can move ahead and use it, try and apply it in his application. But in the behind that one small soundx function, this is the complete algorithm which runs behind. So just to give a brief, when you have Smith and Schmidt, the example which I took, what happens is the first letter is taken constant. So the first letter, there's no modification done to that. And all the vowels and A, E, I, O, U are all dropped, and they're not taken into consideration. And you kind of group similar sounding consonants with a particular number. Like for example, you substitute M and N by 5, you substitute D and T by 3. So when you do that, whatever be your spelling, your soundex key remains the same. And that's how you can differentiate between the two, and you can then use this key to make analysis or to further use it in your application, right? A metaphor is something which has a different algorithm, and that is something which I leave it to the users to explore. With that, we would then move on to the next one, which is basically edit distance. Edit distance is a very fundamental and very commonly used concept. So what it really does is you need to quantify when you have two strings, when you have S1 and you have S2, how different are they, and how many operations do I need to do in order to convert S1 to S2, right? So when you, for example, you have intention and execution here. So what are the different kinds of operations you can do? We can insert a character, we can delete a character, we can substitute a character, and we can transpose a character, right? So these are all individual operations with one cost. So when I talk about edit distances, how many such operations need to be done to convert the word intention to the word execution? So if you see here, the edit distance will be actually equal to 1, 2, 3, 4. So it takes four operations for you to move from intention to execution, right? So this is a very basic concept of edit distance. But now with the concept of edit distance itself, like you can see here, there are 5 different algorithms which work with different permutations and combinations and logic using the same 4 operations. So when you want to use it, it's again one line. You give jellyfish, you call the Levenstein distance algorithm, and then you give the 2 strings. What you can see here is when you say edit distance 2, it means it takes 2 operations to convert jellyfish to smellyfish, or be it jellyfish to FIHS. And here you have the similarity and similarity index. But how do you know all of them work on the same concept of edit distance? So when you're working on an application, how do you know which algorithm to use when, and which is more useful for your particular use case? So let's dive deep into what Levenstein is, what Demirel-Levenstein is, and what least common subsequence is, right? So Levenstein is, it only uses insertion, deletion, and substitution. It doesn't take into consideration the transposition feature of it. So to give you a small example, let's say this is a very common mistake which all of us make, RECIEVE. So when you want to convert receive to the word RECEIVE, what you see is you need to do basically 2 substitutions, right? So that's why the edit distance is 2. But let's say you also have RECIEVE or RECEIVE and you want to move it to received. The edit distance is still 2. So both of them are valid suggestions, but both of them have very different, they are very different semantically, and they are used in very different contexts. So that is where I think Demirel-Levenstein algorithm comes into play, and it was introduced by a scientist or a computer engineer called Frederick Demirel, and he improvised it and came up with the 4th operation, which is transposition, where you can do character swapping. So when you have an edit distance 2 here, with this algorithm, you can do it using 1. And the least common subsequence is it's actually a competitive programming an algorithm for those of you who have done that. So it predominantly just uses insertion and deletion. So just to give you an example how it differs, let's say you want to move from kitten to sitting, right? So Levenstein uses just three operations. It uses substitution, and then it uses insertion. Whereas longest common sequence, because it is allowed only insertion and deletion, it uses all the five, it takes 5 steps to reach the same output. So this is where you see the difference between two algorithms, and you can take a call as to which algorithm you want to move ahead with. So just a few more examples, few more algorithms is Hamming distance. A Hamming distance only takes into the account of substitution. So when you only take into account substitution, you need to make sure that both your strings, the lengths are same. And when you move into Jarrow and Jarrow-Winkler algorithm, they only use it with the basis of transposition. So basically, you need to have, this is used when you have multiple words, not just one word. So that's where edit distance and Levenstein distance kind of fails, because when you have 2 or 3 words and you have mistakes in each of the word, it takes so much more time and so much more operations, right? So then we come to the last part of the whole spell checker is the symmetric delete spelling correction. This is something which is 1 million times faster than any other algorithm which we have discussed. But why is that? It's because it only uses the concept of delete only candidate generation. So it doesn't do insertion, it doesn't do substitution, it only does deletion. But how it does is it has a dictionary behind. So it has a corpus, and the dictionary will have words and the frequency numbers, right? So let's say let's say you have a word goal, or you are inputting GOA. So the dictionary will already have the word goal and goat. And let's say you delete a character, you delete the last word L. So what you get is you get GOA, and you get an input entry of GOA. So basically, you do not do any alteration to the input entry. When you modify the dictionary entry, and you simultaneously also modify the input entry and make sure those two deletions match. If that is the case, then that particular word which is in the dictionary is right. So this concept helps you, instead of having 3 million possibilities, it helps you to generate only 25 possibilities for a word, for a 5-letter word, with an edit distance of 3. So this is why symmetric, which is basically SymSpell. So that's the package which can invoke this, and these are the functions which you have: verbosity and max edit distance and word frequency dictionary. So you can customize whether you want the top just one suggestion, or you can customize if you want the closest one, or if you want all the suggestions, you can do that too. So again, an edit distance is, like you said, you give a maximum edit distance which you want the SymSpell to do the number of deletions. And so the create dictionary and the load dictionary is where SymSpell wins, is because you can create your own dictionary with your own words and frequencies. So if I'm working on a corpus which is very different and very specific to a particular domain, let's say retail or medical, this is where you can customize it to your use case and use it. So I do have a small, so SymSpell is something which cannot be imported using just one statement. So I could just show, or probably I could send that link to Akshay, where it loads the dictionary and creates it, and then you give a sentence, and there are basically 2 or 3 different kinds of functionalities. You have a lookup functionality, you have a lookup compound functionality, where you pass on one word, and it is able to check from the frequency dictionary which we have loaded, and then it gives back the response. Or even if you want to segment your word, let's say you have the quick brown fox and you have it without a space in between, it will help you to segment it into words and give out the response, right? So with that, I would love to take any questions which we have.
Great session, Niharika. I'm sure everybody in the audience, enjoyed it. So let me just quickly, go through the comments and check for questions.
Okay. If we have time, I could squeeze in that small code base which I have.
That depends, because we're practically running extra time now.
Right.
So I don't see any questions as of now.
Awesome. Okay.
So yep, I think you pretty much made it crystal clear to everybody here watching. So I request you to take any questions offline if you could, if any pop up. Okay. So once again, it was great having you at CC Days, Niharika. Thank you so much for being a part.
Thank you. Thank you so much for
And
having
okay, so we
me.
just
Okay.
got a question.
Yes. How is spell check being done for multilingual texts? Yes. So this, like I said, all of this is based on a corpus which is behind, right? So the corpus is built on English words at the moment. All of this will work perfectly fine for English. So let's say you want to do it for another language like Tamil or Hindi or any of it. So you'll have to uh, uh, actually have that corpus first and then modify your algorithm in such a way that it handles that. So each language has its own semantics, it has its own what is it, grammar and structure and spellings. So there are open source Indic tools which are there which handle multilingual text, but not the tools which I explained today because those are primarily for English. I hope that answers this query.
Great. So yes, so like I said, if any other question arises, so I request you to go offline and take it on the YouTube streaming link.
Okay.
Apart from that, I think it's been a really awesome session and
Thank
great
you.
having you again as a speaker for Cloud Community Days. Hope we collaborate on our future events as well.
Definitely. Thank you. Thank you for having me.
Yeah. So thank you. With that, guys, we've come to the end of all our phone sessions. So let me just quickly go ahead and share my screen. So we'll be breaking for lunch at 1 o'clock. So do join us back at 1:40 for a quiz time. And we are having a quiz time where we are giving away, like rupees 5,000 worth of Flipkart gift vouchers. So please do join us for exciting, like for a chance to win this exciting gift. Also, these are the rules for the quiz time. For the quiz form will be provided in the comment section, and it accepts the responses only from 1:40 to 1:50 p.m. Basically, the rules of the quiz are like it will have 5 multiple choice questions, and all the people who answer all the 5 questions correctly will be selected for a lucky draw. So a random and so a program will be run containing the list of names of all the people who answered all 5 questions correctly, from which 6 random lucky winners will be selected. So all the best to all of you, and we expect you here after lunch as well. Also, a humble request: if you are enjoying all our presentations, all our content, please do subscribe on our YouTube channel or on Facebook or Twitch. So yes, that's pretty much it. So do join us back after lunch, and see you guys. Hey guys, so we are back online. So hope all of you had a good lunch. Right now it's time for the quiz. So we're having a quiz time from 1:40 to 1:50 p.m. The lucky winners, who are six winners, sorry, will get rupees 500 worth of gift voucher. So yeah, so let's quickly go ahead and get on with the quiz. Let me just quickly, let me just quickly get you through the rules. So let me just go ahead and share my screen to you. So yeah, these are the rules for the quiz time. If you haven't followed them, please. I'm just displaying them once again. So the quiz form will be given out in the comment section, and the form only accepts responses between 1:40 to 1:50 p.m. Winners will get rupees 500 worth of Flipkart gift voucher. So let me just go ahead and send you the quiz form. Guys, just a quick reminder. So I'll just show you how the quiz works. So let me just go ahead and share my screen to you. So like this is a quiz form which I believe all of you might have received on the comment section. So please hurry up and fill it before 1:50 because the quiz ends at 1:50. The form stops accepting these responses after 1:50. So please do hurry up. We have about around 7 minutes left. So each of the fields are required for you to qualify as a winner, as a potential winner. So as you can see, there's a name, email, phone number, and these are the questions. So each question has 1 point. So the winner will be chosen on the people who answer the fastest and those who answer all questions correctly. So among those people, all the people who have answered correctly and who have answered the fastest will be chosen, and a Python program will be run, which contains the names of all such people, from which we will be choosing 6 random lucky winners who will be getting rupees 500 worth Flipkart gift voucher. So these are the questions. So please do go ahead and fill them. Also, guys, requesting you to check out the learning resources, which are the link to the learning resources is provided in the description of the video, along with the feedback form link. So those who want a participation certificate, please do go ahead and fill out the feedback form. Also, also do remember to like subscribe to us on YouTube, Facebook, Twitter, and Twitch as well. So if you like the content and if you like what we do, please do share and support our stuff. So just over 4 minutes to go until we stop accepting responses for the quiz. I already see a lot of responses coming in. Please do hurry up. We have great upcoming sessions for the plan for the afternoon sessions. So just over 3 minutes to go till we stop accepting responses for the quiz, guys. I already see so many responses coming in. Thank you. We've been overwhelmed by the response for Cloud Community Days as well. So a big thank you to each one of you for making this special and making this happen. Just 2 minutes until we close all responses for the quiz. Hope you guys have filled them. So like we said, the only people who get every answer right and those who do it the fastest will be selected. And a program will be run containing all the names of all those people. And among them, we will be choosing 6 lucky winners who will be getting each a 500 rupee worth, Flipkart gift voucher. So please go ahead. For the last 1 minute until we stop accepting responses for the quiz. We do have an exciting, an amazing session coming up for the afternoon session. We have exciting speakers and really great topics to be covered. So please do stay with us. So yeah, the time is 1:50 p.m. IST, and we are officially closing the responses for the Google Forms. So thank you to everyone who's participated. The winners, like I said, will be announced in the evening after the end of today's events. So the winners will be announced by around 4 p.m. IST. So please do stay tuned. Also, coming up, we have an exciting session from Vishal Biani. So yeah, let's not waste time and let's just get into it. So let me just quickly go and add Vishal to the stream. Hey Vishal.
All right. Are we live?
Yes, Vishal, we are live.
Cool. Just give me one second. I'll share my screen.
Yes. So how are you, Vishal?
I'm good. I'm good. How about you?
I'm great. So really exciting having you as a speaker for CC Days here. So if you could just quickly go ahead and give everybody an introduction about yourself and your topic.
Sure.
That's awesome. Yeah.
Right. Cool. So today we are going to talk about magic scaling event pipelines with KEDA and Virtual Kubelet. And my name is Vishal Biani. I'm CTO and founder at InfraCloud Technologies. I keep dabbling typically with Kubernetes, serverless technologies, and some of the new exciting technologies in the cloud native landscape. We also run the Pune Kubernetes meetup, and we've been running it for a few months, of course, virtually now. So please feel free to join us every month. We have some really exciting talks from the local speakers and community about their use cases and interesting technologies. Great. Cool. So since we are doing this talk after lunch, I thought a menu metaphor might be a good one. So what we are going to serve today is what I'm going to talk about. So we'll start with the first starter plate, which is KEDA. We'll understand what KEDA is, what it does. Then we'll go on to Azure Container Instances, which is a very exciting piece of technology I've been following for a bit. And, some very interesting ideas there, and there is a lot to be explored yet. The next plate on the menu will be Virtual Kubelet. We'll see how that relates to Azure Container Instances, what it does, and what it can do for us in this demo. And then finally, what we do is we stitch together the ingredients from the first three dishes, so to speak, to build our magic scaling pipeline and go through the code and then go through actual demo. And then we'll eventually wrap up with questions, caveats. And of course, every situation or solution is based on context. So what I'll explain is, the demo might work great in some context. It may not work great in so much other context. And we'll walk through that. And for anybody looking for Candy, the code is on GitHub. Go ahead and feel free to check it out later now whenever you get a chance. So yeah, cool. So even before we go into event pipelines and scaling them, I think it'll be good to level set in terms of what event pipelines are really, right? So today we look at many applications, integrations. The data flows from one place to other place. It does something and then goes to some other place. So there are a bunch of things happening which are event driven, right? All of us are definitely very familiar with many message queues like Kafka or NATS or RabbitMQ or ActiveMQ, and inherently all these pipelines are event driven. An event happens somewhere and that gets pushed into either a message queue or someplace, and then that message queue triggers a worker thread which might be processing something and then passing that message further on down the lane into the pipeline, so to speak, right? And the typical characteristics of these kind of workloads is that you suddenly need a lot of compute capacity. So let's say every minute some event happens somewhere and that produces 1,000 impressions or events. We are basically talking about just for that 1 minute after an hour, all the 1,000 events kind of need to be processed, right? So, and then once the events have been processed, I think you want to scale down the compute to 0, kind of stay idle. That's the typical characteristics again, right? So that's the kind of event pipeline we are talking about here, because the pipelines and event could mean different things to different people. So I thought it will be good to level set the context here. All right, so let's start with the first dish, KEDA. So what is KEDA? So KEDA is an open source project from Microsoft. It's acronym for Kubernetes Event-Driven Autoscaling. At a very fundamental level, I think it does two things really well, and that's what it is really best at. It activates a deployment when an event happens. So let's say a message appears in a message queue, or a change happens in a database row or whatever, right? That's an event. And as soon as that event happens, it informs or activates somebody that, hey, an event has appeared. You need to wake up and start processing, right? So that's a 0 to 1 kind of event. And once events have started appearing, the first worker has started consuming those events. KEDA also actually helps you in scaling the worker processors from 1 to n. So let's say the first event appears, you go from 0 to 1, but there are a lot more events. So based on certain matrices and monitoring, KEDA will auto-scale your deployment from 1 to n. And last point I didn't mention is once the events have been processed, it again brings that scale back from n to 0, or n to 1 first and then 1 to 0 first, right? So it's meant to be a way to scale out and scale in your actual processing, like processor worker object, so to speak, right? All right, so how does it do this? So those of you who are familiar with the general Golang and the Kubernetes terminologies, it achieves it using two objects. And even if you're not aware of those terms, I'll briefly explain how it is achieved. So the first thing you create is something called a scaled object. So it is very similar to a Kubernetes pod or a Kubernetes deployment spec, but it is of type scaled object. And apart from metadata in the spec, if you look at it, you specify a target reference deployment. So what this means is this is the deployment that should be activated if there is an event. And the polling interval here, we are specifying 30 seconds. And then in the trigger information, we are specifying what trigger should this deployment be activated on. And in the example that I'm showing here, we are talking about Kafka. And in the metadata, we pass all the information. For example, the servers to connect to, the consumer group to talk to, the topic on which to watch for events. And this metadata, of course, will vary from trigger source to trigger source. For example, in Kafka, there are these 4 parameters. In case of NATSQ, it could be a completely different set of parameters. And in case of Prometheus, it could be another set of parameters altogether. And then you also pass reference to something called as authentication reference, which basically holds information of how to connect to this Kafka server here. But scaled object is primarily tasked with capturing the information as to whom to activate and what is the trigger. Now, going to the second object that it uses to achieve this is the trigger authentication. Trigger authentication is relatively simple. It basically is an encapsulation of multiple secrets which hold various pieces of information for a given event source. So this is a very specific one for Kafka, for example, where we are specifying the auth mode, the username, password, the certificate authority, the certificate, and the finally key. So, it's just a list of secrets that you will need to authenticate with your message source or event source, let's call it. Now, let's see how this actually works in practice, right? So, KEDA supports a bunch of sources for events, right from Amazon SQS to Redis to NAT streaming, RabbitMQ, Postgres, or even Azure Service Bus, or Azure Event Hub. And what a user does is it creates a scaled object and trigger authentication, as we saw in the previous examples. And you also create the deployment. So deployment is your actual consumer job, which is going to process the message from the work queue and do some output. And once you create the deployment and these two objects, KEDA actually creates the horizontal pod autoscaler for you, which actually enables you to scale the object from 0 to 1 and beyond that. Now, once a message arrives in the message queue, KEDA is basically watching here that, hey, is somebody sending a message? And as soon as the message arrives, it is going to activate this HPA and deployment. So it's going to bring up the HPA to 1, and then deployment, of course, replicas 1. And there is one pod that is spinned off to consume these messages. Now, as more messages arrive, it's going to scale out your deployment. And again, this scaling is, decided and depending on how you configure it, whether you want it one consumer per message, or whether you want it a consumer could handle multiple messages, but scale out based on either CPU or memory or some other parameter, right? Like some other custom metrics as well. So KEDA will scale out these, and once the messages have been processed, it will again bring it back to 0. So no more consumer objects lying around basically. What I really like personally about KEDA is you can integrate with a bunch of these sources for events and still maintain a pretty low footprint of the consumer objects, because your consumer objects are actually being dynamically created and destroyed based on events. So that's a very basic introduction to KEDA. And as of today, they support these many scalars, as they call it, at various levels. So there is Kafka, there is NATSQ, there is bunch of them, but that's a pretty broad coverage for any event-based pipeline. All right. The second exciting dish on the menu today is Azure Container Instances. So what is Azure Container Instances? It is probably one of the most simplest ways to run and deploy a container that is out there today. All you need to do is write your code, build a Docker image, and your Docker image is ready. Simply use the container service to deploy it. So it's a completely managed container service. You don't need to worry about virtual machines. You don't need to worry about any orchestrator like Kubernetes or Mesos or Swarm. And you don't need to manage anything, no VMs to manage, no orchestrator to manage. But it still provides you hypervisor isolation. So if I have to simply deploy my application, for example, in the command below, I'm showing like a simple Nginx deployment. All it takes is a simple command. Of course, I have to write the code and build the Docker image and be sure it does what it does. And then I can configure a bunch of parameters, whether the IP address should be public or not public and those kind of things. And that's it. So it's a great way to bootstrap applications, and from just a source code and a Docker image. Sorry, I was just not on full screen, so I just changed that. So that to me is a very useful service to bootstrap applications. All right, the next thing on the menu is virtual kubelet. So what is virtual kubelet? So for those of you who are aware, in Kubernetes, there is something called as kubelet. A kubelet is nothing but responsible for managing a given node in the Kubernetes cluster. So if you have 10 nodes running, you basically have 10 kubelets running, one on each node. And it manages everything that is on that node, all the containers running, all the networking, the traffic, the storage, and stuff like that, right? So virtual node is nothing but virtual kubelet is nothing but a kubelet, but it is virtual in the sense there is no real node that you're managing here, but you're managing an external service. And as of today, virtual kubelet supports a bunch of services. So ACI being one of them, the one that we saw in the previous few slides, Azure Container Instances. It also has support for Fargate. It has support for Ali Cloud's container service and a bunch of other services. And inherently, what you do is when you say I want to schedule a pod on this virtual kubelet, you specify certain taints and tolerations to make sure it goes on that node. But inherently, you're scheduling that pod or container on an external service like ACI or Fargate. So technically, you're dealing with the same interface of Kubernetes, writing a manifest and deploying into Kubernetes, but it is running somewhere else, for example, in this case, ACI, right? Now, how do you do that? So first of all, of course, you'll need to install virtual kubelet in your Kubernetes cluster and then connect that to a provider. In our case, the provider is ACI, which is Azure Container Instances. And we'll again quickly look at how to configure that, how to install that in the demo section. And then once you do that, you'll actually see a virtual node in the cluster. So let me quickly show that. So if you look at the nodes here, I can see two nodes. One is a real node, which is from AKS pool, and the other is a virtual kubelet node. It is a ready state, and it has specific version running on it. So you get two nodes, and you can schedule your workload on any one of the nodes, the normal machine node or a virtual kubelet node, basically. All right. So now coming to magic scaling pipeline, which is where we are going to combine these three ingredients that we cooked earlier to make a real recipe or a dish out of it. So what are we going to do? So the first thing so there are a couple of components. So first thing we have is a publisher deployment. This deployment is nothing but it is connecting to a NAT server and writing a message. So it's a publisher pod basically. And this pod, again, we are going to schedule on the virtual kubelet, not on the actual real node in the Kubernetes cluster. So as soon as we deploy, it's going to get scheduled on the publisher as a publisher pod onto Azure Container Service. and it's going to write a message to the NATS streaming queue through service host. Now, as soon as the message arrives in NATS, KEDA is going to be watching on it. So we'll have KEDA pre-installed before we actually go there. And KEDA is going to say, hey, there is a new message. I need to do something about this based on the scaled object and the authentication trigger object that I have. So it is going to inform the deployment to activate. So before it informs, the deployment is going to be at 0 scale, and HP is going to having 0 out of 10 pods. And as soon as KEDA informs, it's actually going to go and schedule or make the scale to 1, and that will schedule an actual consumer pod in the ACI. Now, since more messages are arriving, it is going to scale that deployment from 1 to multiple pods. I have shown 3 here, but it could be any number really. And once all these messages have consumed the messages, it is going to destroy and bring it back to 0, right? So that's the end-to-end magic scaling pipeline that we're going to talk about. All right, now let's switch to the code and demo. Cool. So this is the same code base that I showed earlier, which is on the GitHub as well, and you can go and check it out. So the first thing we do, and some of these steps I have done earlier in the interest of time, so that we don't end up running into issues or waiting for something to get ready. So I have created an AKS cluster, which is Azure Kubernetes Service Cluster. So for that, you first need to create a group, then you need to create a service principal, and then you need to create finally a cluster. Once you have created the cluster, we get the credentials of the cluster, and that way our kubekernel is configured locally, so we can actually connect to the cluster and see what's happening. Then, taking all these parameters that we kind of produce in the first stage, we set a bunch of parameters. For example, what region are we in, what resource group are we using, and stuff like that. And that is useful for us to actually install Helm. Virtual kubelet using Helm. So then we install virtual kubelet, and then virtual kubelet is successfully deployed there. Once virtual kubelet is deployed, we also set up KEDA. So KEDA is again a very simple, two-step process. You create a namespace for KEDA, and then add the KEDA core repo to your Helm repository list, and then you simply install, KEDA. So that is the kind of basic setup. Now for our magic scaling demo, I have actually used the NATS demo from the this GitHub repository. So for that, I have also installed NATS. So NATS is again a very simple installation. You create a namespace and you deploy the Helm chart of NATS, and you're good to go there. Now, one thing that we have done kind of a little hacky, and I'm going to talk about that a little in the end, is technically the Kubernetes cluster resources, which are running on the actual real nodes, should be able to talk to the ACI nodes, which is running in the Azure Container Instances and other way around. But right now, there is an open bug in the virtual kubelet repository, which is that the ACI pods can't directly talk to a resource in the Kubernetes cluster. And that's why what we do is we actually use a Nginx ingress controller and expose the NATS pod that we created earlier, or deployment that we created earlier, onto TCP. And for that, it's a very simple process again. You need to configure a couple of ports that you need to expose and point to the right namespace and the right name of the NATS deployment and expose the right ports. So instead of trying to reach directly within the network, we have taken a little longer hop that going all the way to load balancer from the TCP port forwarding and going to the NATS pod instead of going directly. But once these two issues are resolved on the virtual kubelet repo, that kind of should go away. So that's the setup that I have done so far, which is what it is ready. I'll quickly show that to you so that you're on the same page as me. So I have NATS running in the stan namespace, and then I have KEDA running in the KEDA namespace. And you can see there is KEDA operator, and then there is KEDA operator metrics API server. These are two components that KEDA deploys. And in my normal or default works namespace, I have the Nginx ingress controller running, and then virtual kubelet deployed as well. And just to confirm, my virtual kubelet is running still fine. Just let's check the logs, and that's looking good. Great. Cool. Now let's go and look at the other components that we are going to use. So the deployer pod, which is what we talked about earlier on. I'll just go back to the diagram so you're also on the same page. So this deployer pod or the publisher pod is what a simple NATS writer. And if you look at the last section, the line number 31 to 40, these tolerations and node selector ensure that this pod doesn't get scheduled on the normal node, but on the virtual kubelet node. So this is on the deployment pod. Similarly, we also have a subscriber pod. And again, very similar. We have basic definitions, the replicas, the image that we use, and a bunch of parameters. But I think the last part is what is important, that it's a node selector and tolerations, which ensure that this pod actually goes to the virtual kubelet and not to the normal node. And then also we have the scaled object, which is a KEDA scaled object, right? So as you can see, we have defined a scaled object, and we have defined a bunch of parameters. But the most important part, we are referencing here to the subscriber pod's deployment name. And since we are going to deploy the same namespace, I don't need to specify the namespace here. But GoNet sub is what the subscriber pod is, as you might have seen in the deployment here, right? And then we are saying the polling interval has to be 10, the cooling down period has to be 30, and a bunch of other parameters, and then pointing to the actual NAT server. Now, you must be asking me, hey, where is my trigger authentication object? So in case of NATs, we haven't configured any trigger authentication object. Right now, we're just using a simple open NAT without any authentication, just for the sake of brevity of this demo. But you can technically do that. All right, so that's like the code walkthrough. Now, I would say let's go ahead and deploy and see if it works. All right, so the first thing I'm going to do is I'm going to deploy the consumer pod first. And I'll tell the reason why I'm going to do that. Because my consumer pod has to be ready before the publisher pod puts some messages. Right? So I'm going to do slightly other way around. Let's go back to the CLI and do that. Right, so I'm going to deploy the subscriber. And we'll see that the pod is getting scheduled. Oh, it's terminating, that's weird. Oh, I see what's happening. The reason that is because we actually already have a scale object, and it has reduced the. Okay, I should have probably done this earlier on, but I'll still explain and go ahead. So if you actually now look at deployment, I can see my GoNet subscriber already has a deployment created. But what KEDA did, because I had already deployed the scaled object beforehand, and I forgot to delete it in the previous iteration, is that as soon as I deployed it, it killed the pod, but it still kept the deployment. So all it did is scaled it back to 0, basically, right? So KEDA has already kicked in here, and let's look at the log of KEDA so that we are clear on that as well. So yeah, so it has picked up the deployment, and it says, hey, I have identified deployment, for which you already have a scaled object, and I'm going to scale it back to 0 because there's nothing happening right now, right? Now, let's deploy the second component rather. And I'm going to keep this in the watch mode so that we see the new pods getting created as we go through. And also, let's look at, is there any container in the Azure container instances? So we can see nothing here. That means there is no container running in the Azure container service right now. Now let's go ahead and deploy the publisher pod. So this publisher pod is not managed by KEDA for obvious reasons. Now, as we have deployed the publisher pod, we should be able to see it in the AZ or the container instances. In Azure container list has one pod that we just defined has deployed. So this is the publisher pod, by the way, just to be clear. But on the other hand, also see that suddenly the number of subscriber pod has started going up. So let's see what's happening there. As we can see, the subscriber one has bunch of them are getting created. And we should see the same effect on the Azure container instances, that bunch of subscriber pods are getting created. Some of them are pending, some of them are running, but as we can see, a bunch of them are getting created. So if you now look at it, for one publisher pod that I created, there are a bunch of subscriber pods getting created. And let's look at the logs of the publisher pod as to what it actually pushed out. As you can see, the publisher pod published about 10 odd messages, I believe, roughly 10. I might be wrong a little bit there. And for each message, KEDA has actually created like one subscriber, container, so to speak. Some of them have failed, but most of them have succeeded. And we might restart that one subscriber pod. Now, what will be interesting is if you go and look at the subscriber pods, and let's look at the logs of one of them maybe. So it received a bunch of messages, 3 messages. That is 2mm2h. Let's look at another one maybe. That received message number, some other message numbers. And similarly, let's look at a little bit at the bottom. Yeah, so as you can see, the messages have been consumed by these subscriber pods, and they are still executing, I believe. As long as we keep the publisher pod running, it'll keep running, I believe. So now let's go ahead and delete the publisher pod. Right, so now we can see the subscribers are still running. There is one failed subscriber. We can try to restart it actually. Easy container restart. Now that's my name, this, and then the resource group is this. That's going to take a while. Yeah, so as we can see here again, all of these pods are not running on my Kubernetes cluster. They're actually running on a different node, which is virtual kubelet. So only my Nginx ingress controller and virtual kubelet is all that is running on my actual real node. All of the other ones are running on virtual kubelet. So technically, I haven't provisioned a single new machine, but I'm able to process all the messages that I came, and they kind of pass through. And also to show you the nodes again, so we have just one node Kubernetes cluster, and the other node is really a virtual kubelet cluster. A couple of them have failed. Let's see what's going wrong with them. We can maybe do like a okay, that seems a little odd, but just a couple of them actually. Most of them are looking good otherwise. Cool. As we can see, many of them have succeeded. Most of them are otherwise either pending or updating, but overall the execution has went well. So without provisioning a single new machine, I was able to process a bunch of these pods. So technically, we can extend this to a much larger number of messages and potentially also much larger number of pods getting created on the fly, getting executed, and then kind of dying so that the work is done. They kind of go back to earlier state. So while that cleans up, we'll just really go through a few more slides and then come back to see what is left of the Azure container instances. So I think one of the fundamental questions that definitely you might ask is, hey, why do all this? Why not simply run like a machine or whatever, right? So my answer to that would be, we can keep the static infrastructure in the static cluster, just 1 or 2 nodes running, minimum whatever required. And whenever an event comes, burst into Azure container instances and then kind of come back. And then all of the event processes is now handled by ACI, which is a completely managed service, so that I don't have to manage that infrastructure, look at the scaling part of it. Somebody else is kind of taking care of me at that, as a managed service. And the best part I really like about this is you're scaling at the container level, not at the virtual machine level. You don't have to extend a virtual machine. You just add a container into Azure container, it spins off, executes the task, and then it is done. You kind of kill it, so to speak. So I think this is a great use case for many intermittent workloads where you expect a little bit of volume periodically, but not consistently. But again, this is very contextual. Your mileage might vary, and you should choose based on what problem you're trying to solve in the first place. And a couple of caveats and hacks. As I mentioned earlier, because of one bug in the kubelet, virtual kubelet, the ACI kubelet pod can't directly talk to NATs, although they are in the same cluster technically. And that's why we had to expose the NAT server publicly. And the other, not caveat, but more like something I took a shortcut is, if you look at the HPA, let me go back and show on the CLI once more. If you look at the targets, it says unknown. So this unknown comes from the fact that we haven't tied up this HPA to a metric server, and it can't determine based on certain factor like CPU or memory whether to scale out or scale in or whatever of that sort. And something this can be done in an ideal world, but of course I haven't done for now. And one of the interesting things that I'm doing right now is I'm actually integrating KEDA, the very first thing that we saw with Fission. Because in case of Fission, it's a function as a service platform, and we basically want to enable like dynamic scaling, for certain events, and just execute the function and then kind of die out, so to speak. So the Fission KEDA integration should be released in the release 1.11. That will be coming somewhere in the mid of July. And Fission is a function as a service platform on top of Kubernetes, just for your knowledge. And then there is another project that we are working on, which is BotCube. It's a open, it's a bot for your Kubernetes cluster. It supports Slack, Microsoft Teams, and a bunch of other messengers. You can talk to, Kubernetes cluster through the bot, actually. And lastly, one small kind of, plug from outside. We have a CNCF webinar that we are presenting on BotCube next Thursday. It'll be at 10:30 IST, so this is 10 PST in the night, and we'll be talking about how do we use BotCube, for various auditing and reporting use cases for our customers. All right, so I think I'm kind of done with my session and demo. I'll just read out the questions and probably answer them. Is that okay? All right, so the first question is from Manoj. Knative and KEDA have some commonalities like event-driven HP, etc. Any thoughts on when one should be used over the other? So I think this is a very good question. I think what KEDA does is purely from the source of events to scaling a certain task, whereas that actual task could be the function. It could be a wrong learning process, or it could be something that runs on a VM, right? So I think they are in a way complementary, where the KEDA takes care of listening to events and invoking something, and Knative takes care of actually invoking the function and doing something. And this is what exactly we are also doing with Fission, where KEDA is acting as the facilitator of event sources, and then actual execution of function is done by Fission. And that's why it kind of makes, perfect complementary sense. Cool. Next question we have is from Manish. Virtual Kubernetes is only for Azure Cloud. Can I install it on-premise? If yes, that is like adding worker node without using KubeADM. That's a very nice question. And so as of today, if you look at the Virtual Kubernetes website, it actually only lists like ACI, the Fargate, AWS Fargate, a bunch of other cloud providers have also similar offering. I believe Google Cloud has something, I don't recall the name. But if you talk about on-premise, I think the way we'll have to do is there's another provider there called KEP, if I remember the name right. It actually adds a virtual machine as a virtual node or virtual pod into the cluster. I haven't checked it out myself, but that could probably do it on premise. But yeah, this is kind of primarily meant to be on cloud offering. And the other way you could do it is, of course, run your cluster on premise, which is what the static capacity you have. And for all the dynamic capacity, burst into ACI or burst into Fargate or burst into any other provider, basically.
All right, Vishal. So we have one question from Sandeep. I'll be flashing it on the screen.
Business use cases, I would say it's purely scaling based on events. So more like if you want to save cost on dynamic events instead of paying for the 24/7 running a virtual machine, and if you want to run it only periodically, that's where I would say KEDA kind of makes sense.
Okay, great. So we have one more question.
What is the importance of intra-cloud technology? I don't know. I understand the question entirely. If it means InfraCloud, we are a company who does cloud native transformations, and we do a bunch of open source contributions in these technologies. But I don't know if that is a question that was asked.
Yeah, so probably that was. All right, so if you guys have any other questions, please feel free to drop them in the comments box. Vishal is, live with us, and he'll be answering them.
Cool. Thank you so much for hosting me.
Yeah, so Vishal, it was great having you as one of the speakers for CCDs, and thank you, thank you so much for sharing your knowledge with all of us.
Cool.
So guys, any other questions for Vishal, please? Okay, Vishal. So I'd request you to take the questions offline as well, if you could.
Sure.
So
I'll do that. Thanks.
yeah, so that's great. So hope we could collaborate on our future events as well.
Absolutely.
Absolutely, Vishal. So great having you, and thank you once again.
Thanks.
So that was Vishal. He is not yet backstage. So until then, let me just quickly mention this. So once you guys fill out the feedback form, please wait till Monday to receive your participation certificates, as we're overwhelmed by responses. So please give us a couple of days to process your requests, and all your comments and feedbacks are very important to us. So please do mention them on how we could improve our services to you. So next up we have Nancy. So let me just quickly go ahead and add her. Hey Nancy. Hey Nancy.
Hi. Hello.
Yeah. So how are you doing?
I'm good.
Awesome. It would be great if you could, give a brief introduction about yourself and the topic you're going to be presenting today. And once again, it's an honor having you at CC Days. It's a real pleasure.
Yeah, thank you so much. Hi everyone. This is Nancy. So today I will be speaking on service mesh and why you should use it. I am a software engineer. So I think let's get started. Just a second.
So
Hello.
Nancy, if you could go ahead and add your screen.
Yeah, I'm sorry. I think I have some net connection issue. So just give me 1 second.
Yeah, no issues. And to everybody commenting in the comment box, really glad to see your feedbacks, guys. So really glad to see all this energy and enthusiasm even after a heavy lunch. Really looking forward. Yes, Nancy, I see your screen, so I'm adding it to the stream right now.
Yeah, so I'll just stop my camera because I think I have a net issue. So,
sure. No
just let me know if if you're able to see the slide.
Yes, it's clear. So
Okay,
I'll just
thank
go ahead
you.
and tell you to get on with it.
Yeah, cool. Hi everyone, this is Nancy, and today I will be talking about service mesh and why you should use it. A little bit about me: I am a developer at Grofers. You can find me on GitHub, Twitter, and I really love to explore DevOps and the development in short. So yes, so we are going to talk about service mesh. So when we talk about service mesh, it's like an open source project. Like we have an open source project Istio, right? It's the way to control how different parts of an application share data with one another. So unlike other systems for managing this communication, service mesh is a dedicated infrastructure layer which is built right into an app. This visible infrastructure layer can document how well and different parts of an app interact. So it becomes easier to optimize communication and avoid downtimes as an app grows. So yeah, so this is something which I just this is something a very simple architecture, microservice architecture. So like if we discuss this, we have like each part of an app is called a service, right? And it relies on other service to give users what they want. So if a user of an online retail app wants to buy something from any shopping site, they need to know if the item is in the stock. So the services that communications so the service that communicates with the company's inventory database needs to communicate with the product web page, which itself needs to communicate with the user's online shopping cart, right? So to add the business value, this retailer might eventually build a service that gives user in-app product recommendation. So this is something which we can add over, right? But this new service will communicate with the database of the product tags to make recommendations, and it also need to communicate with the inventory database. So we can see how much interconnection there is in between the microservices, right? So yeah, so it's like so all the modern applications are based on this microservice structure, and they are often broken down in this way. So as a network of services as a network of services in which each is performing their specific business function, and in order to execute this, they are divided into different services, and it is handled by different teams, right? So yes, so this is where now this is something which becomes complex, right? The connections and everything, and this is where we need service mesh, so that it can route requests from one service to the next, like optimizing how all the moving parts they work together. Like just example, just consider a case where there are a lot of requests in your inventory database. So you need something to control it, right? So there we come with the picture. Now when we discuss about this, one question comes in our mind, like, don't microservices already do this? So yeah, so to question this, like definitely a microservice architecture, it lets developer to make changes to the app services, right? Without the need for a full redeploy. Now, unlike app development in other architectures, individual microservices are built by small teams with the flexibility to choose their own tools and languages. So basically, microservices are built independently, and they communicate with each other, and can individually fail without escalating to the application wide range. So service to service communication is what makes microservices possible, right? That's the essential part of it, which is the communication between different services. Now, the logic governing communication can be coded into each service without a service mesh layer. Like definitely we can go without a service mesh layer. We can definitely do the code into each services. But then again, it's going to be very complex, and I'm going to discuss that later. So yeah, so for cloud native apps built in microservice architecture, a service mesh is a way to comprise a large number of discrete services into functional applications. So if we talk about traditional service to service communication, we can use libraries, REST, gRPC. We can also implement manual traffic using Hysterix or RX. We can do load balancing. We'll have to write explicit service discovery code. We might be using Consul or Kubernetes. Since you are developing applications over a while, you may or may not have updated service maps, right? So you will not get you'll not get to know that where a particular call is going. And the worst thing is you have repeated this code over all the services in different ways. So which means all the time developers are basically less focused on business calls, but they are more focused on handling these service communications. So it also means that communication failures are harder to diagnose, because the logic that governs the inter-service communication is hidden within each service. But what if we remove all these complexity and do communication in the naive way and push all this to an infrastructure layer? Like just imagine that everything is controlled at infrastructure level and not at the application level. So here we come to the deeper of service mesh. Now, this is a service mesh, which is an array of network proxies. Service mesh doesn't introduce new functionality to an app runtime environment. apps in any architecture have always needed rules to specify, right, how requests get from point A to point B. Now, what's different about Service Mesh is that it takes all the logic, which is governing the communication part, out of the individual services and abstract it to the layer of infrastructure. So that all the handling of this is done at infrastructure level. Now, to do this, Service Mesh is built into an app as an array of network proxies, which you can see in the diagram. So in a Service Mesh, requests are routed between microservices through proxies in their own infrastructure layer. So for this reason, individual proxies that makes up a service mesh are sometimes called sidecars, right? As the name suggests, sidecar. It's like something which is running alongside, right? So exactly. So all these sidecar will be running along all the services, and taken together, these sidecar proxies decoupled from each services, and they are decoupled, right, from each services, and they form a mesh network. So yes, now. So this was about the architecture of Service Mesh. Now we have discussed that why do we need Service Mesh, and we also have discussed that how Service Mesh looks and how it works. Now, what we actually achieve when we are able to implement this. So we have automatic load balancing, right? So we have a mesh network, right? And each proxy is aware of the other proxy. So they can easily do automatic load balancing. And the network layer behavior are put as config in your proxy so that you don't have to write explicit network management code. And it also handles service discovery, right? It provides service level visibility and telemetry, which helps enterprises with service inventory information. It also provides reliability because you're able to monitor things, right? Metric data from Service Mesh allows you to see how your services are performing. So, for example, how long did it take to respond to service requests and how much resource it is using. So this data is useful to detect the issues and correct them. So it is also able to give us a monitoring aspect. Then you can do traffic governance. Like with Service Mesh, you can configure the mesh network to perform fine-grained traffic management policies without going back and changing the application. This includes all ingress and egress traffic to and from the mesh. You definitely have an access control. With Service Mesh, you can assign the policies that service request can granted only based on the location where the request came, and can only succeed if the requester passes the health check. And definitely there's a secure to service communication. If we go next, so we studied that why we require Service Mesh, and we have seen that what Service Mesh architecture looks like and what we get from Service Mesh. Now, these are some of the softwares which we can use for the implementation. We can use Istio, Consul, Linkerd, and all of these are supported by Azure. The containers have become the standard for cloud-native application deployments. And Microsoft offers the tools like amazing tools like AKS to help manage containers with Azure environments. And with the help of this, we can implement with Istio, Consul, and Linkerd. So if we talk more about Azure, then Service Mesh integration organizations, for example, instance, like take Consul, right? It can securely bridge both native and non-native Microsoft environments through a number of integrations with Azure services. So these are some of the examples. And concluding the lightning talk today, we have learned that Service Mesh is an amazing concept, and it basically helps developer focus on adding the business value instead of connecting the services. Instead of focusing more on code, they can focus on adding business value. And apps are more resilient to downtime, since a Service Mesh can reroute the request away from field services. Then performance metrics, it suggests ways to optimize the communication in the runtime environment. And it also it's helpful because we are getting rid of many things which was not possible earlier. So yes, this was all about the talk. Thank you, everyone.
Thanks a lot, Nancy. That was really good session, and I hope people would have liked it. So, we'll be taking a few questions from the comment box. Is it
Okay.
fine? Yeah.
Yeah.
Okay. There is one question. Yeah. Can you see the question?
I'm not able to see in the. Oh,
You can
okay.
see it on your screen, on the StreamYard screen.
Yeah. Okay. So the question is, can service mesh replace API gateways? API gateways have an overlap with service mesh in terms of functionality. They may also have an overlap in terms of technology used, for example, Envoy. So I guess, in my opinion, yes, but I think I need to explore this option more, and I will get in touch with you, Sandeep, over this. We can have a discussion offline.
Okay. Cool.
Yeah.
So the next question is here by Abdul.
Okay. What is the relation of data science to the service communication? Okay.
I think
Yeah. I think the question is, like, if data
what
science
is the
require
yeah.
like if data science really require the service to service communication, right? So I think this is a very so I think it depends, right? If you have any model which requires the data science, and it requires the microservice architecture, then definitely we are going to require this, and it's just an abstract layer, right? So yes. So this is the answer for this. I hope it's clear, Abdul. It depends on how you implement, right? If it's a microservice architecture, then yeah, good to go.
Fair enough. So I think we have time, so we can take two more questions. So there is one question from Mustafa.
How service mesh is different from Azure Functions? Um, Azure Functions. Uh, so I am not sure about this answer, but as far as I know, we can implement service mesh is something it's a different concept, right? And we can use this with Azure or Kubernetes. It's independent of that. And so yes.
Okay. So I think we can take the last question, which is related to the best resources from where they can learn about service mesh.
Oh, the best resources, I think I always prefer the official documentations. That's I'm too much opinionated for that. So I think it's always good to start with official documentations, but when I was so I think it's good to start with I'll say for official documentations, and then check out the blogs definitely. Because check out the blogs of Twitter and different companies who are implementing this already.
Okay, cool. So I think regarding the previous question, there is one participant from the audience box, Dhananjay. So he has answered for the last question that Azure Functions are serverless offering, and
Oh.
both are both have different concepts.
Okay.
So this was regarding to the previous question. So thanks a lot, Dhananjay.
Thanks, Dhananjay.
Yeah. Okay. So I think that will be all. Thanks a lot, Nancy, for joining us for the conference.
Yeah.
We are really overwhelmed to have you, and I hope the people would have liked the session and would be taking something out of it, and would implement in their regular things.
Yes.
So
Thank you so
thanks a
much.
lot, Nancy. Also, we'll be sharing your slide on the learning resources with the participants so that they can go through it as few people are asking for the learning resources.
Awesome.
Okay. Thank you, Nancy. So that was Nancy. So next we have Niloshima. So Niloshima is yet to join us. So in between that, I will show you the learning resources page where we are updating all the speaker slides and few learning resources which you can go through. Let's show you. Yes, so this is the learning resource page we have. So the link is con.me/ccd learn. So you can check out this page and go through the learning resources. All the resources are totally free. We have free ebooks as well. So we have learning resources for different categories. For example, we have for AI and ML. Then we have for like DevOps. We have for Kubernetes. We have for serverless. Then we have the speaker slides for all the speakers. So we have updated day-wise speaker slides. So this is for the day one. These are for the day two speaker slides, and these are for today's session. So you can go through this link and find all the speaker slides and access them. So few people are asking for the feedback link. So guys, we'll be sharing out the feedback link by the end of the day, and we'll also be announcing uh, the quiz winners and the referral contest winners by the end of the day. So please guys, keep patience and uh, do do stay with us till the end of the day. So we'll just wait for some time for Niloshima. Okay, so guys, since Niloshima is yet to join, so maybe we can get started with Anisha's talk. So we'll have Anisha next. Hi, Anisha.
Yeah, hi Rohit.
Yeah,
Hope you're
how you
doing
doing?
good. I'm doing good. What about you?
I'm doing good. Actually, the current session was for Niloshima, but she is yet to join. So I think you'll be fine with your session.
Yeah, okay. Yeah. So,
Yeah. Okay. Cool. So Anisha, like going further, I'd request you to give a quick intro about yourself, what you're doing, and what your talk is going to be about. And meanwhile, I'll share your screen on the screen.
okay. Yeah. Sure.
Okay.
I'm Anisha Swain. I am an associate software engineer at Red Hat, and I have been a part of Red Hat's performance and scale engineering team since a year. I have been a part of open source since last 4 years, and I have been contributing to various projects, and I have created various projects in open source as well. So today I'm going to talk about open source itself, and I'll give a brief idea about how to what's the exact meaning of open source and what do we mean by open source software and free software, and how to get people started with open source. So that would be all about my talk today.
Cool, Anisha. Anisha, can you share your screen so that I can put it on the screen?
Yeah, sure. So let me know, Rohit, if you can, this is visible
Yes.
to you. Okay.
Yeah. Anisha, your screen is live.
Okay. Let me know when we can start with this.
Yeah, you're good to go.
Okay.
Good.
So good afternoon, everyone. As I have already introduced myself, I'm Anisha, and an associate software engineer at Red Hat. And I have been doing open source since last 4 years. And today we're gonna talk about open source in brief. So without much introduction, let's step into the world of open source and see what we have got here. So open source is a very broad field and can't be covered in 15 minutes, but I'll try my best to give you a brief idea about when the whole idea of open source started, and what exactly is open source, and where and how you can get involved in that. So, as most of us might already know, much of world's largest companies are open to public. That means anyone can download the source code behind it. If a program is open source, its source code is freely available to its users. That means the user and pretty much anyone else have the ability to take this source code, modify it, and distribute their own version of the program. Open source software allows developers to stand on the shoulder of giants, I would say, and create their own software. So we can actually say that open source has taken over the world. Now, open source development by sharing the concept of sharing and collaborative approach and giving free access to software source code has a history essentially as long as the software development itself. Uh, in around 1900s, software was a finite commodity. So it used to get accumulated and wanted to be sold as a product. At first, open source software was was only maintained by a dedicated few, and in late 1990s, interest and participation with this initiative increased remarkably when the Linux came into mainstream recognition. Later in 1998, Open Source Initiative was formed as an educational advocacy and stewardship organization, which is indeed an important moment of the history of collaborative development approach. More detailed history of the open source initiative can be found from the opensource.org website itself, which I have linked in the slide, which will be shared later. As we have already discussed, open source software is software with source code that anyone can inspect, modify, and enhance. So source code is the part of software that most computer users don't ever see. It's code computer programmers can manipulate, change, and how a piece of it's actually how a piece of software or a program or an application works. So programmer who have access to computer program source code can improve that program by adding features to it or fixing parts that doesn't work correctly. This can be done with more efficient and collaborative and for me natural approach using open source. Now I want to draw a distinction over here. When we talk about open source, we actually come across two terminology: open source software and free software. The concept of free software was introduced by Richard Stallman in 1980s. The focus of free software is on what the recipient of software is permitted to do with the same. It means that the user have the freedom to run, copy, distribute, study, change, improve, or enhance the software. Open source applications are generally freely available, although there is nothing stopping the developer from charging for copies of software. That's not what free software refers to. The free here is by mean free as in freedom, not free as in rupees or dollar. Free Software Foundation focuses on ethics and morals of using software that can be controlled or modified by user. In other words, it focuses on user freedoms, and the open source software movement was created to focus more on practical or pragmatic reasons. It advocates wanted to focus on practical benefits of having open source software that would be beneficial more to the business rather than ethics and morals. However, both terms refer to essentially same set of license and software, and each term implies just different underlying values. However, the concept that we are going to refer to in this talk is FOSS, which is free and open source software. Free and open source software is software that can be classified as both free and open source. So open source doesn't mean just access to the source code. The distribution terms of open source software must agree with the following criteria according to the organization. So free distribution of the project, according to this, the license shall not restrict any user or group from selling or giving away the software as a component. Then the source code, according to the open source community, the program must include the source code, and it must allow distribution of the source code as well. The source code must be in a preferred form in which programmer can modify the program. Now, it also must allow modification and derived works from the original project, and must allow new changes to be distributed as well. Now, there is a slight trick here. It also talks about integrity of the author's source code, which means we can also restrict the source code from being distributed in modified form only. So the license will allow the distribution of patched file only, not the original one. So yeah, open source strictly follows no discrimination against any person, group, or any field or any endeavor. And now I'm not very sure about how license thing works, but it does say that the right attached to the program must apply to all the child program without requiring any additional license, and it can't be specific to a project. And it also ensures that license must not place restriction on any other software that is simultaneously getting distributed along with the open source software. The closed source software will not have any restriction of the licensed open source software. So that's the flexibility over here. Now, why should we use open source, and what are the advantages of that? So open source is community driven. We can connect to the best developers around the globe, and as per flexibility, we can learn from their experience and even can read their code and see their approach. It's very adaptable and it's very easy to get hooked. In open source, you have all kind of freedom that you want. Your voice matters over there. And it also maintains quality and efficiency. So that's I think that's a place good to go. Talking about how to contribute to open source softwares, we can get plenty of open source version control system for the same. As most of us know already, version control systems are a category of software tools that help a software team manage source code over time. Version control system software keeps track of every modification or every mistake in a very special kind of database. If a mistake is made, the developers can just turn back the clock and compare the earlier version and fix the mistakes. This minimizes the disruption and also helpful while doing collaborative coding. I have listed some of the version control system I am familiar with, and I'm sure the list goes on. But here are some of the most commonly used version control systems like Git, CVS, Apache Subversions, abbreviated as SVN, Mercurial, Monotone, Bazaar, and etc. So feel free to explore this part of version control systems. Now, the question is how to do it. So a common misconception is when we talk about open source contribution, people think that you have to contribute code, but it's a misconception about contributing to open source. And in fact, it's often the other parts of the project that are most neglected and overlooked. You can, there are provision where you can organize the project's conference or handle their social events. You can restructure layouts to improve project's usability, or put together a style guide to help the project have a consistent visual design. And the favorite part of me will be you can also write and improve project's documentation, which is a huge help. Now, if you want to contribute technically, there are a couple of ways to get started with the projects, like creating own project. Every project should start with an identified need. If you feel that existing project on the GitHub or Bitbucket or any other VCS don't offer functionality you'd like to build, then create your own open source solution. It's as simple as that. You can also find many projects, like thousands of projects there who are free to and you're free to participate in on GitHub, which is like most popular when I talk about open source. It's a developer-oriented platform with a simple but essential set of functionality. So it attracts developers with public APIs, a sleek and frequently updated UI, and Jest for doc, and much more. So you can contribute to free software in many ways, and can fork the projects and make changes to code, or make changes to documentation and send pull requests. Also, you might consider making alternatives to commercial websites. That's another thing to do. So there isn't any hard and fast rule when you contribute, but people do follow some general etiquettes in open source contributions. If there is a documentation, do read it, because it will have essential information about the project. And also, as a project owner, it's always a good idea to add README files or contribution guidelines for new contributors. Then looking at the existing issues before opening a new one, because the issue might just be a duplicate of the old one, and which makes it very messy to keep track. It's also always a good idea to provide as much info as possible when reporting a bug. For example, if you're reporting a design bug, then it's a good idea to add a GIF image or a video, so that the developer can just get to know what exactly the issue you are facing with. If there are contribution guidelines, then follow them. And the three most important thing that I would say is to be empathetic and understanding, collaborate and cooperate with other people in your community, and say thank you for people who have helped out with the open source contributions. I have also added some resources in the slide if you want to get a detailed overview of what are the etiquettes that people follow. That isn't a hard and fast rule, but just good to follow. Now, the most important question, I think, is who can contribute to open source? And the answer will be you. Any one of you can contribute to open source and be a part of this huge family. So I guess that's it from my side. I would like to encourage each and every one of you to be a part of this large community. And for me personally, I would say open source is a way of life, because ultimately it's all about helping each other and collaborating and be empathetic towards a better future. So thank you, and let me know if there is any questions.
Thanks a lot, Anisha, for the talk on open source and why people should contribute to open source. I think there are a few questions on the comment box. And okay, so there is one question from Ismail. I'll just pop it on. Yeah.
So the question of Ismail is open source or paid software, which is the best? So I would say open source is, because you can get like same quality, same efficiency, along with flexibility to report and enhance the code base, and I mean, what else we need in a piece of software? So I would go with open source, definitely.
Okay. So I think there are no further questions. But anyway, like if there are any questions coming up later on, Anisha, you can go offline and answer few of those questions from YouTube comment box itself.
Yeah, sure, Rohit. I think there is another question that I
Yes,
would
yes,
like
yes.
to.
Sure. Yeah.
Yeah. Anurag asks how to start contributing in open source as a freshman. It is difficult to start, so some piece of advice. So Anurag, first of all, it's not at all difficult to start because you see, there are projects in. I would say GitHub has a very nice user-friendly interface. So start with GitHub, and even in big projects which has a very complicated code base, they usually have like good first issues. So they will have labels like good first issues or easy bugs, so you can get started with them. And if you are having trouble in understanding the code base, you can always comment on the issues or join their talk channel. You can join their channel, either it's a Slack or GitHub, anything, and you can ask the maintainers directly your doubts. And I'm sure like people who are working in open source are collaborative and supportive enough to answer your questions. And even if you are not getting answers from there, other people will be looking at the issue and following the issue who will get back to you. So yeah, I think the best idea is just to get started without thinking much.
Cool. I think that answers the questions.
Yeah.
So thanks a lot, Anisha,
Okay.
for joining us today.
Thanks
It
a
was a
lot,
really
Rohit.
good
And
session.
yeah, thanks a lot,
Yeah.
Rohit, and all the organizers for having me here. Thank you. Thanks for being a wonderful audience, guys. Thank you.
Thank you, Anisha. So that was Anisha from Red Hat. Next we have Niloshima. So I'll just quickly add Niloshima to the screen. Also, guys, in between the talks, you can post your questions through the comment box so that the speakers can go through it and answer them at the end of the session. So, hi, Niloshima.
Well, hello everyone.
Yeah, how are you doing?
I'm doing good. What about you, Rohit?
I'm doing good. So, thanks, Niloshima, for joining us. I know there was some bit of like less of coordination
Yeah.
initially. Yeah, but still we got you. Yeah. So, yeah. So, from where you have joined for this session? Is it from Gurgaon?
Yes, from Gurgaon.
Okay, great. So awesome. Niloshima, going further, you can give a quick introduction about yourself, of what you're doing, and what your talk is going to be about. Meanwhile, you can share your screen so that I can put it on the screen.
Okay. Let me know when you are able to see.
Yeah, it's there.
Okay.
It's live.
Okay, fine. So guys, thank you so much. I'm going to talk about, okay, Rohit, is it in presenter mode? No.
Yes,
Okay,
it's live.
fair enough. So thank you so much, guys. I'm going to talk about, understanding Azure Batch Services today. And in just 15 minutes, it will be a little tough for me, but I'll, try to give you more and more, what I can give you. So the introduction is part of this, presentation. So I don't want to, waste time in my introduction. So let's move ahead. So this is me. I'm basically a cloud architect, and I'm a mentor, I'm a blogger, and I'm a speaker, and I'm a developer by choice. It's been 12 years in the industry, and I've been working with Microsoft technologies. I have been, I've been part of some big brands and some small organization startups as well. If you want to reach me, you can write me email on niloshima@brewingcoach.com, and you can Google me. I'm very easily to find. So yeah, that's pretty much all about me. So we are going to talk about a couple of things today. We'll be talking about what is Azure Batch and what are the core services Azure Batch is offering. Then we'll talk about what is the hosting and processing architecture of Azure Batch, and then we'll do a quick demo using Azure Portal. So Azure Batch. Let's understand. We all know that why do we want to move to cloud? The major goal of moving to cloud is more or less, cost saving, operation expenses over capital expenses. There, Azure Batch Services comes into picture if you would like to run, a huge job, a huge workload, right? So you can upload your batch jobs into cloud, and you don't have to worry about the resource management of that particular job, because Azure will take care of that job for you. So let's understand what is a batch job. A job that needs to be rerun multiple times, on maybe a different pieces of data or same sort of data, same set of data, can be a good example of batch jobs. So it's like a simulation, right? So if we want, let's say if you wanted to run a weather prediction, or probably rendering a movie, lots of identical tasks are there that can be running in as parallel, right? So we can consider those jobs that batch jobs. So Microsoft will basically manage and create. Microsoft Azure will create the VMs for us, for that particular specific 100 number of tasks. The resource allocation will be done by Microsoft Azure. So instead of having a single VM that takes, let's say, 48 hours to do a simulation and render a result, then you can have Azure Batch Service and have that done in parallel, perhaps probably in an hour or two, to have the answer instead. So there are a couple of things which we need to understand while starting Azure Batch Services. So there are Azure Batch Services are they offer these three features to us, right? Azure does the resource management for us, right? So by resource management, what I mean here is that Azure is going to be doing our node management. In our pools, we have to create pools, and then there will be a couple of nodes which will be responsible for executing that particular job. The auto scaling of that particular nodes and that pool is also managed by Azure, as and when it is required for number of nodes in the pool, right? So we Azure will take care if we would like, if there is a job that is taking like 10 minutes, Azure we can also assign low priority nodes, right? So when I'm saying that assigning low priority node, what I mean here is that you get the option. Not each and every node will be your low priority node, but you get the option to use low priority node, and when it will suit your workload. So why would you use low priority node? Low priority loads, probably you'll be using if you don't have a definite sort of time frame in which you want that particular simulation, that particular batch job to run, right? And apart from it, under resource management, you can, if you would like to work with an application, you can basically assign that particular application to to that particular pool and task, right? And then this Azure Batch Services, it helps us in process management as well, right? What I mean by process management here, what I mean by process management here is basically it will do jobs and task management for us, right? So the jobs, whatever jobs we will be creating in Azure Batch, will be part of that whole process, and we can create multiple tasks in that particular job as well, right? It will also manage task dependencies for us, where we are gonna plug and play the dependencies, and Azure Batch will take care of the execution. And we can also run multiple instances of that particular task, right? So it is basically a way to if you have like chunk of data to process, let's say 100 files to process, you can basically go ahead and do that. Process management can be done. That process management can be done via this Azure will manage, right? the third portion of this interesting feature is basically the resource and process management. What I mean by resource and process management is that Azure will give you a beautiful monitoring portal within the Azure portal as well. And then you can also, there is a tool called Batch Explorer. You can install it locally and see how it is basically helping you. I'm going to quickly show you the image how it looks, and I'll quickly show you the Batch Explorer on my machine, which is running. And you can also use resource and monitoring, that process monitoring for application insights, right? And there are a couple of matrices available, which are available through the API. They are REST-based APIs. There are .NET based API, then Azure CLI, then Azure PowerShell is also there if you would like to run your commands on over the on the Windows PowerShell. So apart from it, let's so like I've discussed, right? These are the portion which we have covered in resource management. It'll do resource management for it. It'll also scalable. Then we get to have low priority nodes if you want to save the cost. And then it is also it also manage the application infrastructure for us. Process management have jobs and task management and the task dependencies, and we get to have multi-instances tasks, right? And this is all about resource and process monitoring, right? So like I said, we have Azure Portal monitoring, we have Batch Explorer monitoring. We can easily use the application insights portion, which is on the right bar of the Azure Portal. You can just see there's an insight thing there. And then there are a couple of matrices available, which are available to REST, .NET Core, Azure CLI, and so on and so forth. So this is how your portal monitoring will look like. So you can see, right? There are a couple of jobs which are running. These squares are the nodes which are anyways running in the portal. We can start the task. We can upload the application packages here with this, and this this will give you an idea that what and all nodes are running, what and all nodes are how many nodes are idle or basically starting or probably rebooting. So these nodes are basically your compute compute power, right? It may be a couple of containers, it may be a couple of virtual machines. So Batch also support Docker. That's one more interesting thing. This image gives you the idea how can you monitor the particular task in terms of I have a pool. Let's say I have a job. I have a pool. In that pool, I have a job, and then in that particular job, there is a couple of tasks which are supposed to run, right? This is how you will see that, okay, out of 100, 80 tasks are active, 20 are are already running. As of now, no task has been failed or probably succeeded, right? So this is how your Azure Portal monitoring will look. So this is a desktop based tool. It is available for Mac. It is available for Windows as well as Linux. You can use this Batch Explorer tool for monitoring your job. So what I'll quickly show you how does it look. Basically, it's a tool where you have to select your storage account, your batch account, and then you'll quickly be able to see how many nodes are running and what and all is happening, right? So let's say if I'm creating this Azure batch and I go to job, so this is how it will look. As of now, I have no jobs running, but this is the active job, and this is the this is the job schedule. If I want to schedule any job, I can just go ahead and schedule it from here. This is the pool which I have created. So these many tasks have errors in the execution of that particular job. I have also a couple of packages available there. I have basically uploaded an exe file which is called Polyray. So this is how you're going to manage your the whole the whole monitoring process on your desktop itself, right? So having said that, like I have mentioned, right? How does it look, right? This is how it is supposed to be. It will look, right? So this is how you're gonna see and check how your desktop application is going to run. And this is the best part about this is that this is an open source project, right? So like I have shown you that in in the Batch Explorer screen that you get a lot of matrices here. You get you can check what are the number of failed tasks, if there are any failed tasks in that particular event. This is the portion, you will sign in with your subscription, and then to use that particular Azure Batch service, you have to have an Azure Batch account and a storage account associated to it. So this is basically your batch accounts, and you have to select that batch account, and you will be able to see these couple of matrices, right? So that's another thing. Move ahead and talk about the hosting architecture, right? How does it work when you have to host your batch code, probably, or your application, right? So it's basically work in the Azure world. You have to have a subscription. Then you have to be your resource group is something which is mandatory. Resource group is basically a logical container sort of relationship in which you can create resources. So you get to have a resource group, and then you have a couple of batch accounts, right? Under that batch account, you have pools. So what are pools? Pools are basically the nodes on in pools are basically you are giving the Azure this this information that I have so many so and so number of nodes available. You can just pick anything from there, right? So this is, then you have to have your applications for using those your applications. You can probably zip it in a zip file, and you can have to just zip your exe and upload it over the Azure portal. You get to use certificates as well. And for all this thing, there are two things which are mandatory under that particular resource group, is that you have to have a batch account and you have to have a storage account. Storage account is basically required for processing your input and output files. So let's say if I have to render an image, I have to have a storage account where I'll be uploading my image, and in that storage account, batch whenever the batch process is executed, either successfully or probably failed, it will going to switch pass on the output there, right? So this is how the hosting is done in the Azure Batch service. Now let's try and quickly understand what is the processing architecture. How does it process basically? So I have a batch account. I have an application, like I have told you, right, that I have an exe file. You have to zip your exe file, and then you have to create a pool. And in that particular pool, you will be creating a couple of jobs, right? And then with the help of that, a job can have multiple tasks that I have to create. Let's say I have a pool ABC, and I'll be creating XYZ a job. Then I can create task 1, task 2, task 3, task up to 100, right? A number of tasks I can create, right? And this will be this will be your infra which you will be creating. You will be assigning a couple of properties, like what is the node count you want, what is the region you want, and so on and so forth. Post that, you'll have to have a storage account, like I've already mentioned. In that particular storage account, you'll have resources file, your input files will be there, and your output files will be there. And then if you would like to use some SQL Server or Cosmos DB, some other storage service, you can use that as well. So this is how basically it processes. Batch account goes Azure. When you are signing in your batch account, you have Azure will look up for your for the applications which you would like to use. Then it will look up for the pool, then it will look up for the job. And in that particular job, whatever task you have created, let's say if you have created task 1 to task 10, it will start working on that. The moment you are creating the task, it will assign that particular task to a particular node, and then that particular node, your whole process will start executing. So that's there are a couple of limits and quotas which are probably or basically a part of which comes like in a whole package. So there is as of now there are per batch accounts per region per subscription is 1, 2, 3. You can have maximum 50 default 50 batch accounts. As of now, dedicated codes per batch account, right? Codes is basically your CPU, your compute nodes. I'm talking about compute nodes here. You can have the default is 90 to 900. The maximum is still unspecified. You can go like a number of accounts if you are just willing to pay, right? If you have such priorities job which you would like to run rather than running it on premises, you would like to run in cloud. So if you are willing to pay, it's pay as you go. You can create a number of dedicated batch cores per batch account. Then you can also create low priority. The default is basically 10 to 100. It is also unspecified. You can create a number of low priority nodes. And let's talk about active jobs and job schedules per batch account. You can basically have something in between 100 to 300, and the maximum is 1000. There is also a quota on pools basically. So pools per batch account has to be maximum 500, right? And the default is close to 20. So the minimum nodes which let's say if I've created a pool, so the minimum cores which I get is like 20, right? I've already shown you in that in that particular diagram that there are like 20 boxes. Those are square things, right? Those are basically your codes. These things can also be changed, so you just have to go ahead and check this URL. It will give you the broader idea how to change it, and what and all you need to done, some configuration setting if at all. If you are in some enterprise sort of agreement, it'll help you to quickly just go ahead and talk to your cloud provider, especially in this case Azure. So there are other Azure batch limits as well. So concurrent task per compute nodes has to be whatever node cores you have multiplied by 4. So let's say if I have 20 node cores, I can have 4 into 80. That is, I can have 80 concurrent task nodes, and this is 80 is a huge count, right? I can have in a particular batch account, I can have 20 applications, right? And I can basically execute those 20 applications simultaneously. I can have 40 application packages per application, right? And the maximum task lifetime is close to 180 days, right? So I can basically run a process which is like close to 3 months, right? So this is very flexible, and you can definitely go ahead and change. This is basically, I have a pay-as-you-go subscription, so I'm just telling you in terms of that, right? So you can just, if you have an enterprise sort of agreement, you can just go ahead and talk to Azure folks, and they'll probably help you with this, how to maximize your task lifetime, right? And this computer nodes, you can inter-node communication. If you are using a pool which has inter-node communication, you can have 100 compute nodes. 100 compute nodes, it's a huge number, right? And by compute nodes, what I'm saying is that it can be 100 virtual machine, it can be 100 containers, or some virtual machine, some containers. So this is how basically you can manipulate the resources, and you don't have to manage each and every minute details there, right? So let me quickly show you. I'm not sure if I'll have the time to quickly go ahead and create everything, but I'll just quickly show you that this is basically a resource group which I have created in my Azure account, and so I have basically created this Azure resource group in West US, and under this resource group I have a couple of accounts, right? So this is the batch account. As you're able to see, this is the batch account, this is the storage account, right? So let's see what and all properties we can have in batch account, right? So it has basically, I have also, it is basically region based. I have created it in East US, right? And my subscription details, the subscription ID, this is basically the resource group, and this is the matrices, which I was talking about. I can see vCPU per minute. I can see failed task, I can see the task states, and then the node states as well, right? If you quickly move ahead inside, I have basically this application which I have already, have to go ahead and select application and basically just add it, right? So this is how like you are able to see, right? I can add up to 20 applications. As of now, I have just used this PolyRay only, right? Then in this particular batch account, I have a couple of pools created. So this is a pool which I have created, as of now, this allocation state is steady, but you can see, right? So this is what, I was talking about. This is the node heat map, right? So as of now, probably there are four nodes which have already started, but the task has been failed, right? So this is how you're going to create, and this is so like I have told you, right? Pool is basically your compute nodes, right? Your collection of compute nodes, right? So this is, I have 20 vCPUs, I have 20 dedicated nodes, and I do not have any low priority. I can also go ahead and make this true. So but I don't need, because I was just creating it for demo purpose. And then this is the pool ID, and it is associated to a batch account, and you can see just the operating system, right? I'm running it on Windows Server 2019. So this is standard A1 type of VM, which is more or less like 1.8 gigs of memory, 1 CPU core, right? So that's there. Apart from it, in that particular render pool, I have a couple of nodes, right? So this is my these are the list of nodes which I have created. I have assigned tasks to them. Let's quickly go ahead and see the storage account, what and all data I have in that storage account, right? So I have created this Azure batch storage account, and in that particular batch storage account, again it has to be in the same region. It's again East US, same resource group. It's a standard performance. Access tier is hot. I do not need any replication strategy as of now, else I could have chosen probably ZRS, GRS. This is basically depending upon your needs, right? And the account is general purpose V2, right? So let's go to containers and see. I have basically created two containers. This is demo scene, this is demo frames. Demo scene has my input files, and you can see like I have 100 of files here uploaded, and I just want to execute those. I can add n number. So this is the place, this storage account is the place from where my Azure batch account will access the information, right? So let's say if this can work as an input directory, and then I can probably go ahead and use this like as an output directory, right? So that's how.
Sorry to interrupt you, Niloshima. I think we are running a bit short of time. Yeah.
I'm done.
Okay.
Like I'll take 5 more minutes and then I'm done, right? So this is that is the reason I just didn't show the demo.
Okay.
Let me quickly just wrap it up. So this is how you can also do. I was talking about insights, so you can just go ahead and see it's still in preview. So just you have to see what and all insights are available, what and all matrices are there, right? So you can just go ahead and see other and batch account, and it will show you whatever insights it can. You can also have diagnostic settings and so on and so forth, right? So that's it, guys. I think that I'm more or less done with my thing. If you have any questions, please feel free to reach out to me. Rohit.
Yeah, that was really awesome. Niloshima, I know you had to run and complete all your presentations. Yeah,
yeah.
I can see that. Okay, I'll just take one or two questions from the comment box. Yeah. So here goes the first question. Can you see it on screen?
Yes. So worker roles and are basically web jobs. Worker roles are already part of Azure Batch. So if you have your probably if you have your requirement, which is something like that, where if you want stateless virtual machine, right? If you want platform as a service, if you have limitations around using operating system, you can just go ahead and use worker roles, right? But in a typical scenario, we would go with virtual machines and containers, because virtual machines are more flexible in terms of you get to have many specification options, you get to have many operating system, you have full access to operating system, right? And then again, it's an IaaS offering, so you are more flexible around playing with that particular virtual machine, right? So that's how but as of now, I would recommend that if you are using Azure Batch, you should always go with virtual machines. That'll save you a lot of money.
Okay. So I think I can take one more last question. So it's from
Yeah.
Mustafa. Yeah.
So Mustafa is asking, how is Azure Job different from Azure Scheduler, right? Yes, you can definitely run jobs in Azure Scheduler, but when I'm talking about batch jobs, I'm basically talking about a task which I would like to run on the same set of data probably every day. Let's say if I have to give a weather prediction, right, so to some news channel, right? So this is basically you are performing some task on a huge number of data and on a repetitive basis, right? So that functionality, that Azure Scheduler is not that feature rich in terms of when it comes to you running a huge number of tasks on a huge number of nodes. But apart from it, there are a couple of settings different. The monitoring is also different there. The resource pooling is different there, and so there are a lot of differences. But yes, Azure Jobs make your life Azure Batch basically makes your life easy when it comes to you would like to run your application and forget about it and just came back on another two hours later and your result is in front of you, right? So
Cool. Awesome, Niloshima. That was really cool. And also you tried to answer few of the questions. So anyway, since we are on a very tight schedule, so Niloshima, you can go back offline and answer few of the questions from the comment box itself.
sure.
And
Thank you so much,
thanks a
guys,
lot.
for having me.
Thanks a lot, Niloshima, for joining us today
Thank you
and
so much,
sharing
guys.
your
Thank you so much.
knowledge. Thanks a lot, Niloshima. So that was Niloshima. So guys, we are running a bit late with our schedule. So anyways, we are trying to sum up most of the questions, Q&A session, so that you don't have to go left with your hand. So next we have Minaka. So I'll add her to the stream. Hi Minaka.
Hi, Rogi.
Yeah.
Hi,
How
Rogi.
are you?
Yeah, I'm fine. What about you?
I'm good. I'm good. So yeah. So you are next. So
Okay.
we are running a bit late, but anyway,
Yeah.
you can take your slot, whatever
Okay.
time it was, and try
Take
to
that.
finish. Okay.
Okay.
So going
I will.
further, Bhinaka, I'd request you to give a quick intro about yourself, what you're doing, and what your talk is going to be,
Yeah, okay.
and also share your screen so that I can put it on the screen.
Okay.
Okay.
Are you able to see my screen now?
I'm just waiting for it. There is a share screen button on the bottom.
Yeah, I already shared.
Okay, I can't see it.
Okay, wait. Share screen.
Yeah, I can see it now. You can open your presentation and I'll put it on screen. Yeah. Cool.
Okay.
Your screen is live now.
Yeah. And today topic is leading edge of modern web apps on Azure. And I am Menaka Bhaskar Pillai. I'm working at an associate software engineer at Accenture Digital, and I'm a tech blogger and .NET and Azure certified professional. Other than that, I'm speaking in international conferences. It's my passion to share and learn the technology. That's all about me. Today, we can go to the session, like why we want Azure in all our development platforms like .NET or Java, whatever we are using. We need Azure. It's a cloud platform is playing a vital role in today's all our on-premise. So in cloud, we have some of the futures that is in that's bounds to the next generation. That today I'm going to discuss about those concepts, crisp and clear about DevOps starter. Docker containerization, Azure Kubernetes, and CI/CD pipeline for .NET Core and deploying. Since I can try to cover all those topics, I have since the demo will take a lot of time to load, so I already had a pre-built demo, so I can demonstrate here. Today, what is DevOps Starter? It's we are already have a lot of articles or lot of contribution that's describe AKS cluster, Kubernetes service, and Azure service fabrics, everything. But this DevOps Starter is quite rare term that reaches it hits in past few years. So we need to discuss what is DevOps Starter. It's like you can develop, you can deploy, and you can monitor everything by via means of DevOps Starter. And we can also do all our commit, deployments, build in a single view through the Azure portal. That is the main concept of DevOps Starter. Whatever the changes you are doing in your application that you've been linked with your DevOps account, every time you need to check into your DevOps account, what all are the commits you did, what all are the build you did. Instead of spending a lot of time in checking all those things in DevOps and again back to Azure, we can view everything crisp and clear in DevOps Starter. And the other thing is, like, it can easily deploy your application to Azure. We are taking a lot of time for deployment to AKS because we need to deploy a microservice, means it will take some time to deploy it in a Azure Kubernetes service. But by means of DevOps Starter, all the images, push and publish artifacts are pre-built. It will automate everything. So that's a beautiful concept that DevOps Starter has on its hand. And second main concept is Docker containerization. If you see Docker plays a very important role. Without Docker, we cannot imagine the microservice concept. The Docker image plays an important role when we are deploying that in a AKS. So Docker containerization is one of the key concepts that all the software are packaged, and it contains all the standard units of that are necessary for development, shipment, and deployment. Why we need a Docker containerization is its main concept is platform independent. The Docker image can run on each and every platform irrespective of the infrastructure, and all the build, all your application evaluation, everything can be characterized by Docker containerization. So application evaluation, pipeline, build, and manifesting your application, and maintaining its shipment and deployment, everything can be done, and Docker plays an important role in this. If you see, this is how the containerized application looks like. I have my application that is split into multiple services that can be on hold by means of Docker. Docker is a tool. Containerization is the operation that is done by Docker. So my host operating system and infrastructure will be binded at end. So all together, my entire application will look like a Docker container. So we can see about Azure Kubernetes. If we are already discussed about Docker containerization and other things like DevOps Starter, why we need all those things? We need to do deployment. That's the thing. We need all those things what we seen before. So Kubernetes comes into an action. We read a microservice and we need to create an image of that. Again, we need to deploy that into the Kubernetes. So everything we are doing before or the main purpose of deploying that into the Kubernetes service. So what is this Kubernetes service? It is mainly helpful to build, deliver, and scale all your containerized application, and it removes the extra complexity of managing the multiple container. So I have multiple containers that bounded on each other. I need to maintain and manage each container. It got many problem, because if one thing fails, I can't able to find out which container fails, which is running, which is working, and implementing the container is also very hard in other way. So Azure Kubernetes comes into extent by this means, like it can be portable, scalable, and in an extensible way. And second thing is it manages the load. If you see whether I am creating whether I'm deploying my application microservice in a container in my AKS, it will be as a VM. So wherever the VM words comes, I need a load balancing concept, as well as the resource allocation and scaling. Those concepts are basic concepts of virtual machine. So I am deploying my application in AKS that is creating a VM. So what are the characteristics that VM have? So all those things this Azure Kubernetes needs to satisfy to reach its goal. and self-healing of an application. This is like disaster recovery concept comes into it. Whether any services fails or whether anything goes wrong, it need to self-recovery or self-heal itself so that it not impact the application. This is how about the DevOps workflow with the Kubernetes. You can see the complete entire demo concept I prescribed here. So this is how it will be working. From my IDE, from my local machine, I am creating a Kubernetes dev cluster. I'm tested debugging it. Again, I'm taking the source control of that. I'm using build and release pipeline. Before that, I need to register. I need to create Azure Container Registry for scanning purpose. That will create any other concept that depends for the Azure deployment, my application deployment to Azure. After that, I need to do the Kubernetes production cluster. Once all those things are done, I can able to deploy my application to AKS. This is complete flow chart, how what actually happening from my on-premise to my Azure environment. If you see here, the container image is being created by the Docker that is being displayed here. After that, only my ACR Azure Container Registry is working. This concept being pre-built and pre-done by Azure DevOps Starter. So I don't need to do this by individually when I am doing a new application deployment via my Azure to Azure DevOps. If I am doing from my on-premise, I want to deploy that to my Azure DevOps with Azure Kubernetes with Azure DevOps. I need to do this complete step. But when I am doing for a new application, those steps will be pre-built. So I don't need to build an image and again need to push an image and again I need to copy that into root folder. Again, I need to publish that artifacts. So this is how the demo goes on. If you see, as usual, the DevOps Starter is a service that available in Azure portal itself. You can choose the type of application you want to deploy to AKS. It may be a .NET or a Node.js or Java, whatever it is you can do for independent of the languages. If I am going with the .NET, I have several subsidiaries of my .NET application that include ASP.NET Framework and Core. Because for Core, I will get some of the extract file, and for the framework I will have separate file. So I need to choose the framework I need for my application deployment. After that, if you see, this is how the demo starter pages will look alike. I can able to view all my build, all my release, all my repository, my project homepage via my Azure. I don't need to look after those things on my Azure DevOps. So from directly clicking the build pipelines, it will automatically open my Azure DevOps organization where this project be created. So I will create, so my application being deployed to my Azure along with the external endpoint, while I can use this endpoint to run my application or view my application on my local host. Again, I want to make sure you can see the Kubernetes clusters also being created. I will not create this separately by creating an image. This will automatically created with ACR content. So this is how I can monitor my entire application after my deployment, the health of the application, and how much node CPU utilization it took, and how much memory utilization it took, node count, everything I can view here from my Azure portal. So thank you. This is all about what we discuss about deploying an application in Azure Kubernetes with Azure DevOps. That is why we are having like Azure plays an important role in all modern web apps.
Thanks a lot, Menaka. That was really awesome. And I see a lot of people engaging through the comment box. So, so as of now, I don't see any question for you. But guys, if you have any questions, please drop them on the comment box so that Menaka can answer them.
Yeah.
So thanks a lot, Menaka. Like, if you could find some time, then you can go ahead and answer some of the questions from the comment box. And it was really nice to have you, Menaka, with us for Cloud Community Days.
Thank you.
Thank you, Menaka.
Thank you, Rohit.
So that was Menaka. So guys, you can post your questions on the comment box so that the speakers can go through it and answer most of them. So next we have Sayantika. Sayantika is the last speaker for today. But as you know, this is not the end of the conference. We have few more activities at the end of the day. So without wasting any time, I'll just add Sayantika to the stream. Hi Sayantika.
Hi. How are you?
How are you doing?
I'm good.
Yeah. So Sayantika, previously we had Menaka, and this whole conference is being live from morning 10:30, and uh, we are really excited to have you and hear your session. So going forward, Sayantika, can you please give a intro about yourself, what you're doing, and what your talk is going to be about?
Okay, so even I am following the session from the morning and pretty excited to see lots of exciting talks going on. My session is, I would say, offbeat from the tracks. I will be mostly talking about Django, which is an open source software, and then how you could use some debugging techniques and build amazing visualizations out of it. A little bit about me. I'm a backend developer by day job, and at the end of the day, I'm a community builder and also a board member at Django Software Foundation. If you have any question related to community building and technology, I might able to help you.
That's awesome. So Sayantika, you can share your screen so that I can put it on stream.
Perfect.
Cool.
So that's gonna be my screen.
Yeah. So Sayantika, your screen is live.
Okay, perfect.
Cool.
Hello everyone again. So I think it's been a very long day and you must be very excited to dive into the extra activities that has been planned by the team. I won't take a very long time for this. It would be a 20 to 25 minute intro session to actually how you can debug Django and build insights from it. Little bit what you should be already knowing is basic architecture of Django, which I won't be covering in this session. So if you have little familiarity with the MVT architecture, that is model view template architecture, it would be very helpful and for you to follow through the session. If not, I will be keep on giving you insights as in where you can actually implement in Django, or if you have not at all used Django, that's also perfect. Going back, I hope you would able to have some insights as if how you can implement this in Django. Okay, so today's agenda is this. We'll be talking about debugging techniques. We all know there are many debugging techniques out there, and we have been using it from the entire era of software development. So I will be picking a few of them and trying to explain them and what is the modern tech that we have in order to debug. So a little bit of comparison. After that, I will be talking about few terminology, so which will be I will be frequently using in this entire session. That is logging, and then a differentiator between print versus logger. Might not sound very intriguing, but as in when we dive into it, it will be more clearer why we are emphasizing on the why not we use print nowadays and we are more into logger. And then we will be configuring it with the Django. That is, if you are aware of the architecture, then it would be going into the settings.py, the main heart and core of Django. At the end, the cool stuff will come, which is building insights. Finally, the conclusion. So let's begin. Debugging techniques. This slide actually took me quite some time to actually picturize all my bugs over here, carefully placing them so I could even make this concept more useful for you. So we know that bugs are usually very small, which we say that, okay, we will fix it next time. Let's not worry about it today. Then comes a little bit bigger version of it. Then it becomes a failure. Then the entire software could actually fail. So it's very essential that we don't ignore those small little cute bugs, but fix them right in there. We know that it started with output statements. We love print. Whenever we want to see some variable which is in the runtime and want to see what it is actually having, what is the type of what is the type it is carrying, whether it is int, whether it's a string, whether it's in64 data frame, what is the type of it? So we just do a type of print, type of whatever it is in Python. You might be using Java, so it would be a different output statement. So we use output statement quite often, and that's where we started actually. Now moving forward, we started using flags. It gives us a little bit more flexibility. So we use Boolean flags. Okay, this is entering here, so it would be a true flag. Then it goes to a different functional block and say, okay, this enters here, it will be false. So at the end, we say if it is false, then the test case is passed, or there is no bug involved. Else we go for comments. We tend to use a lot of comments, which is very essential, and we see how the flow is actually going. Finally, we came across debugging tools, which we will be talking about in this session. Debugging tools, how we can use it, and one of it, which I will be talking about, is Logger, which is a Python package which can be extended to Django for debugging it. It already exists here, there's nothing new, but how we can actually leverage the power of that package in Django is the essential part which I will be walking you through the session. At the end, it is identify, analyze, and we need to remove those bugs before it becomes something very, very big, which is difficult for us to debug, or even becomes a very catastrophic failure for our software sometimes. Now we have the two terminologies which we will be frequently using, which is logger and logging. What is logging? I would just take a small example. We used to go to traveling a lot before the entire pandemic came into picture. We used to travel a lot. Someone thought that he or she will be traveling and going for a world tour. Now that person would have started from a country A and then went to a country B, C, D, and we are and in the meanwhile he or she was noting down all the countries and the places being visited. That is something which we can closely look forward to as logging. Logging basically tracks every event. Once a software runs, it is essential for debugging your software. So it tracks all your events as in when the journey continues, and you will be tracking, oh, I went for this country and this was an amazing place. I went to country B and this place was great, the food was great, and you kept noting everything in your diary. And then then this also helps you to fix the crashes in terms of the logger file. If you have anything anywhere which you have a complete log file, you will say, okay, in this country, I must have missed my purse because it was a kind of very crowded country and I have very less time to actually roam across it. And I must have misplaced my wallet or my purse. So it helps you fix your crashes faster if you have a logging event taking in place. Then logger, as I mentioned, the diary is your logger. It helps you write down everything. You are the one who is holding the pen, writing all your events in the form of logging your events, and the logger is kind of the diary which is helping you to log every event. So this is kind of a small example which you can keep in mind to understand these two terminologies which we'll be frequently using in today's session. Moving forward, print versus logger. Some people would definitely convey to me that print is working fine for me. I'm like, perfect. It does work fine for me sometimes as well. But where it fails when there is a very large enterprise scale software that you are trying to build on. Small code snippets, a script or two print works perfectly fine, and you don't actually have to go for Logger. But once your software becomes bigger and bigger, lots of modules, lots of packages, that's when you should use some higher versioning of logging techniques. Print statements, you cannot actually control the information which you actually want. You get all information from all files. You want just one file information, that one function information, and that only goes to your output stream, and you cannot store it, or you cannot do any further action to it. So it's very difficult to control the log information you want to capture with print. Also, you cannot map the severity level that involves in that particular software failure. It might be something, a small error. It might be something, a system failure. Might be your application might have crashed. How would you actually identify? There are many other ways you can identify, and Logger can be one of the ways where you can identify whether it's a critical failure, whether it's just an error, whether it's just information for you. And also timestamps are very essential. It help you at what time the system was down. What's the downtime of the system? This was the downtime of the system, and here are the events that happened in that particular time. Here are the set of events that happened, and this is the downtime. So maybe these 5 events, could one of them be the reason of the failure? So that's how we do the analysis part. And I hope this will help you even in your day-to-day debugging techniques. How would you do that? Get a time. This is a downtime, and here are the events that occurred in that time, and then try to see which of the event was actually responsible for the failure. Moving forward, so Logger, to construct a Logger, you should have the knowledge of these 4 pillars. Without the knowledge of these 4 pillars, it would be kind of difficult for you to actually understand the Logger dictionary object. So the first pillar is Logger itself. The name Logger came from the log itself. So Logger is the entry point to your logging system. What is an entry point? We will be looking forward, but just remember it's an entry point. Then comes the handler. Handler is something like whether you would want the log information to be just on your console, or you would want to be stored in some file, in a file environment, which later you can come back and see, okay, I can come back and see and check what is happening. You can have different kinds of files involved, different data, different types of files. May not be just CSV or TSV or .log files. You can have a multiple file systems. Then comes the filter. In the language of Django, how we call filter is suppose my project is called solar system. I like space. I love talking about space and technology. My project is solar system. Inside that, I have 2 apps called planets and meteoroids. These are my 2 apps. And each app will be having certain amount of files. Say views.py, models.py, vsgi.py, and there are ample of files involved in a Django environment. And I would say that I want the log information from, say, planets app, inside that only views.py, and that too also from only that one method. I don't want the entire log of the entire file, entire app. That's not making sense for the developer. He or she just wants to have that one particular log information going on. So you can even narrow it down to that extent. Normally, I don't actually go deep into the filters part. I kind of do, okay, the data is coming, I'm good with it. I can understand. But if you want to have a more clearer picture, you should definitely use the filters part as well. Formatters is something very similar that you see in any log file. You have the line number, you have the file where the error or the failure occurred, and then you have the timestamp and the error message itself. So this is the entire message that you actually have. That is called a formatter. You can even say, okay, I want only the information regarding the critical failure using a file of only planets.views.py, and the information should contain the timestamp and the error message. I don't want any other data to be there. So you can have that level of flexibility with Logger. You can manipulate that file, you can have build insights, which we will be seeing how the insights, how we'll be building the insights. This is an overview of what in-depth level you can play with the library and implement in your Django architecture. More about Logger levels. Logger levels come under these 5 categories. Debug, information used for debugging purposes, which we put. Okay, we put logger.debug, some information, and done. Info, general message. I want the information to be presented. I'm printing something, or I have reached end of the file, something like that. You can definitely put it here, or you can even put the variable which you are using in your file here. You can present that here. Warnings used for minor fault occurrences. If there is any minor fault occurrences, it can be automatically triggered by the Django, or you can also trigger by yourself. If you have certain exception occurring, you can also put warnings in that. Error, major a problem occur. If there is anything major that is the major problem that is happening in around your application, that's where error occurs. We will also try to do some error, make sure we crash the system, and then an error message is generated. And at the end, information used for critical issue occurrence. Critical is only logged when there is an application level critical issue. I would say not the entire environment of your system will be taken in your picture, but only the application level critical failure would be occurring. If your database crashed, your Postgres just crashed, and or your Redis system or your MongoDB just crashed, you will be having a critical failure message that, okay, something is very bad happening here, and you must just look into the critical messaging part. Example usage. This is how we will be using it. So it will be logger.debug, logger.info, logger.warning, logger.error, and logger.critical. This is the simplest how you can utilize in your methods. We will be also seeing few examples where I will be using a few of them to actually show you how we can implement these. So step by step here, at this point of the session, we understood what is logging, what is Logger. We understood our examples of the world trip and how we are logging the system, and how Logger can definitely help us reduce our failure rates to a large extent. And now the time comes where we actually implement all what we have learned into few slides. I will be just putting you through a few slides, but when you go back from the session, definitely give it a try, and I would be happy to see if there are any errors which I can resolve for you. So basic configurations. So everything that I'm presenting here right now will go to a settings.py file. So you have a settings.py file in your root configuration of your Django project, where this dictionary object will be going here. So Logger, key and value, we all know how a dictionary functions, what are the aspects. So now logging we call as a key, and there is a set of values associated with it. Version, we have to specifically give version, represents the schema version, and schema, when we call in the term of Django, that's your first version of what you are building. That's your first schema version. It can be 1, that is by default given by Django, or you can have something of your own. You can edit that part and present something. I'm at the version 3 or I'm the version 4. You can definitely add that thing here. Disable existing loggers. Django inbuilt has something inbuilt called Django logging systems. Whenever an error occurs, the entire page goes blank and a very big error message comes down. If you don't want that to happen, you can make sure that this is turned to a false. That's the Boolean pattern that you have. or if you would like to have the entire message come down when there is an error occur, which is not advised, here you can have it true. Just for example purpose, it is true, but it's advised to have it false most of the time. Handlers, we talk about handlers that time, and if you remember, we said where actually we want our information to be going to, whether we want it to our console, whether we want it to a file. Here what I'm showing you, I want it to be just somewhere in the consoles. It's a stream handler, so it will give you a stream of output statements, output logging statements. And then comes the root. It will be in the root. And finally, the level is debug. That means all the messages that are of level debug or higher will be logged. So suppose, going back to the slide, if I say I have put my level as error, so you would be getting error and critical messages. If I say I have put something called info, then you will be getting info, warning, error, critical. So that level plus higher. This is a order in which you could say you could portray the debugging mechanism. And similarly here what we say, level is debug. So debug or higher will be coming into picture. Now comes the advanced configuration. Here you will see a lot of other key and value pairs are being added. So what it is? Now here formatter, I have added a formatter. What it is, a standard type. Just you can name it anything that you want. I would just say it's a standard type. I want the timestamp, the level name, the name of the file, the line number, and the critical message or the error message associated with it. You can also read about how you can actually construct this. Pretty simple. There are a lot of other parameters that you can add. I just want these couple of parameters here. And then date format. This is my date format. You can skip the time if you want. You can skip the year if you want. According to you, you can actually put forth the entire formatter. That's up to you, how you would want your logger file to be. Then comes the handler. Now you can see previously we had something called stream handler. Now we have rotating file handle. Now we will see that we will be adding all this log information in a file. And I have just given giving a location, that is temp debug.log. That's my file path. I'm calling the formatter here. Finally, what I have done is that I have chosen the app level where I want only the info and higher information to be there. So here the planets is my app name. As I mentioned, there's a solar system, which is my project, and there is planets, which is my app. Moving forward, meteoroids is another app. So I just want planets, which is my app, which I have, and I want all the log information to go to a file and of level info or higher. You can add another app here and say only critical or higher. So you can control what information would you be needing in your logging system. So that is how you can construct advanced configuration. There are other parameters also which you can add here, but this is a very good starting. This actually covers most of the requirements that you have. And moving forward, I would be giving you a small example how you can actually output the data. So here, as you can see, I have in my views.py two methods. One is just I'm outputting some HTTP response. Others, I am getting the data from my database and putting it in the form of a HTML file and rendering it. For that, I have just created my log. I just wanted to see, okay, whether I'm getting all the data from my database. This is how you can actually do it. If you have the ORM architecture, if you are familiar with the object relational mapping architecture of Django, you could actually relate to this a lot. But if not, when you get back home, you can do a small research and you can understand. But this is how I can just add one statement. And here you have to actually import the necessary imports, and then you have to call logger, which is actually creating a log. there is no restriction as in when how much you can log, what is how many logging statements can you make. There is no such restrictions in Logger. You can make as many required logging statements in your function. So here's a small example where I will show what it is actually doing. So I'm running my server here. That is my Django server. It's in a local port. That is our local port. And then I will be going ahead and showing you the settings.py file. You can see there's an advanced logger information, and I have just what I have shown you in the previous slides. It's already here. And then what I'm gonna do is just print out last few 10 lines of my log file, just to make sure that we are on the same page. So you can see there are lots of debug information that are going forth. Now I will try to log some info level information that we created. Pasting my local path, and then I will be just hitting that endpoint. So you can see there's a endpoint that has been hit, and I will go back and see my logger. So I must able to see something called info. Oh yeah, we have something info. So planning data object 1 and 3, these are the indexes or what data I have in the database. So you can also have what is the endpoint of it and by which port it is being called. There are ample of things that you can do. You can see there is a line number associated with it, which is 17, planet, that is app name, views, that is file name, and the timestamp associated with it. Okay, now the end part, which we have arrived to, the interesting part, I would say. Apart from what we have learned today, you can maximum of it you can find in most of the official documentations. It's pretty vast, which if you go through, but I would say it's very important that you know most of the basic parts so that you can build upon it. Just understand the basics, and it's very easy to then build upon. If your roots are correct, I think the tree will automatically stand tall and high. So that's all it is. So now we will be doing something interesting insights from Logger file. So when we have data, when we have raw data, the first part is processing it. So I was totally blank what exactly I wanted to do with this data. Then I thought, why not give it a try to actually build some insights from it? Maybe it's already done, but I thought that it would be very insightful for anyone to just not see the entire log file, rather build some insights from it and show, okay, this can be a beautiful addition to this entire presentation. So I came up, I took the data, I stored it in a whatever file you would want to, as I mentioned. I did some pre-processing, converted it to a TSV or CSV as per your choice, and then you have to choose your data points. Which data points you actually want the X and Y to relate, or a pie chart to relate to. Finally, insightful visualizations, I was able to do it. And I think you would be if you try this, I think you would be even able to make a much better version what I was able to do it. So I have no doubt that you guys are super genius and you could definitely go ahead and build something amazing out of it. So here, what I did, I just wrote a Python script, and I was able to do the necessary pre-processing out of it. And then I created a small pie chart kind of thing. It's just with a couple of lines, you can do amazing plotting and charting. So here are the labels which I could do it, and this is my output file from which I'm reading the data. Then I'm getting a count of it, how many are actually warning, info, or level type warnings. Then since it's a data frame, I have to convert the int64 to a list, because sizes takes in the form of list. Then I did a small, these all functions are kind of extra to beautify your pie chart, but you can build the entire pie chart from a data of a log file using just few lines of code. Now I'm gonna just run my script and say, okay, my pie chart should hopefully appear if there are no errors. Oh, see, now we have the pie chart up and running. So we see 16% of it is a debug, maximum of it are warnings, and around 24% is info. So we might want to cut down the amount of warnings that we have. Maybe there are no critical failures, so there is nothing called critical here, but we might want to do it like cut down the warnings, increase certain efficiency of the entire program, entire project, and moving and do certain amount of other debugging, essential debugging needed. Then I also tried plotting a similar bar graph using the same data. So I could do the frequency of occurrences and the logging levels. So again, the logging level were similar. So there were two plots that I just for the testing purposes I was building on. One was a pie chart, another was a bar graph. You can have density plots, donut plots, anything that you find interesting. Diving into the code of the bar graph that we saw, you can see with pretty just few lines of code, you could get that beautiful bar graph. And you import the libraries, you count what are the levels in that, you count the plots, and you give some labels. Obviously, a graph without the X and Y labels does not communicate well, does not communicate information well. And then just you plt.show, and this beautiful bar graph appears. Finally, that's not all I would say. There are ample of other possibilities that you can run through, that you can explore. Please do explore and don't restrict yourself with whatever there is in this session. I wish to see that some of you could come up with amazing insights and do something amazing with these packages. There are ample of possibilities and potential in the packages, and we must enforce that everything is open source. All the libraries that I use in this entire presentation are open source. Even the framework Django is open source, so there's nothing restricting you to explore that. There's nothing a subscription that you have to take or something like that. Everything is free and open source, and you can definitely explore everything. Finally, I am pretty much all the time on Twitter. So if you have any questions, you can definitely reach me out on Twitter with the same name, Sayantika Banik. I am on different other social media platforms like LinkedIn, GitHub. Sorry, GitHub is not social media. I'm sorry. So you can reach me there as well. Any questions, I would be happy to take it in person also if you're facing any issues. And pretty much that's all I have for today's session. Thank you for being such a patient audience. Thank you so much.
That was really a nice session, Sayantika. Being the last speaker for the day, still you can see like there are so many audiences still listening to your talk. So we can see like, yeah. So like that was really awesome. Also, Sayantika, I'll just see if there are any questions so that you can answer some of them. Okay. So as we all talk about the advantages of any tool or any software. So there is one question from Mustafa asking if there are any disadvantages of Django.
I have been using it from past few years, and maybe my opinion is kind of biased, but I cannot see any disadvantage related to Django. Django itself, there is a big community which is contributing and improving Django. As in when we are talking right now, there are a group of people in the Django Software Foundation who are working day and night to improve Django packages and help us to actually, if there is any flaws, we can indeed improve those. So my answer would be, I couldn't find any till now, maybe because of the biasness involved. But if you came across anything, I think there might be better packages, but you can definitely explore other options as well.
Awesome. So that will be all, Sayantika. Thanks a lot for joining us today. Also, we'll be sharing your presentation slide with the audience so that they can go through it. Also, we are like maintaining a Git repo where we are putting all the speaker slides with the learning resources.
Sure,
So,
I think I will be sharing those. Not yet. Sorry for that, but I will be sharing
no
those.
problem.
Yeah.
Thanks a lot,
Thank you.
Sayantika, for joining us. Thank you.
Bye bye.
Okay, guys, so that was Sayantika, and with that, we have come to the end of Cloud Community Days. It has been a long 3-day online conference, and we are really thankful to all of you for joining us and being a really patient audience throughout the conference. Uh, so we have seen a lot of questions coming from the audience, and I hope most of the questions were answered by the speakers. Also, if not, you can reach out to the speakers to their given social media handles, and you can put your questions. So, guys, so we'll be joining with Ganesh for the announcement of the winners for the quiz and the winners for the referral program. So before that, I will just show you the learning resources which we have so that you can go through them. I'll just show my screen. So guys, as you can see, this is the conference website. So you can go to the ebooks section. If you click on that, you'll be landing up to the learning resources page. Just a second, I'll show you again. Yeah, so here it is. So you can see all the learning resources and the free ebooks and the speaker slide decks. So guys, you can go through them and use them. Also, we would love to hear from you over the social media. So you can make a tweet using the hashtag #CCDaysOnline, and we would love to hear from all of you. Like, how did you enjoy the whole conference? And also, guys, we'll be sharing out the feedback link through the comment box, and you can find it uh, on the bottom of my screen. So if you have any queries or if you want to give any feedback to us for like further betterment of the future conferences, so we definitely love to hear. Also, I'll add Ganesh for the announcement of the winners.
Hi Rohit.
Hi Ganesh.
Hey, yeah.
Yeah.
Hi to all of you there.
So
So thank you for attending for the 3 days. I hope you had a lot of takeaways from the 3-day session in this conference. So many of you may be new to the topics that are being discussed. Some of you may be already working in the topics that were covered earlier, and some of you may be experts in some of the sessions, right? Topics covered in the sessions. But no matter if you are a newbie, intermediate level, or an expert level user, we are sure you would have found something very interesting and something to take away home. All right, so first I will announce the leaderboard winners. So this leaderboard winners, can you share my screen? Yeah, just 1 minute.
Yeah.
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 Okay.
Slide.
So here is the leaderboard winners. So what is this leaderboard? So we had announced a referral contest. So if you had already registered for the conference, we invited you to refer to your friends or colleagues or somebody in your network or in your circle. And we are so thankful to all of you for referring. So 194 of you referred others. It's quite impressive. Thank you so much for not just showing interest in learning yourself by attending this conference. You have also referred others so that they can also benefit from it. So the winners are here. So the top 10 winners, so they will be getting a gift voucher for $25 from dev.to or from Flipkart. So the winners are, the first winner is Isma, and she referred 196 people. So hats off to you, Isma, for doing such an amazing job in spreading the word about this conference and inviting the referrals for this contest. So followed by Mustafa, Suman Chakrabarti. So not just in this conference, in past conferences as well, and in other contests, in social media. So Suman, you have been very, very supportive about the events that we do. Really thankful for you. At the fourth place is Deepak, Shilpa, Hardik Dharma, Aditya. Thank you, Aditya. Megha, Amar Prusty. Thank you, Amar Prusty, for being a continuous supporter for all our events, and Sweta. So we will be sending the gift vouchers to all the winners by email IDs. So you'll be receiving it soon. And I take this opportunity for you to subscribe to the Microsoft Source newsletter. So if you want to know about any upcoming events, upcoming new blog posts that are trending and so on, please subscribe to this newsletter, and the link is here. And the way to reach it here is ccdays.confab.com, which is the website, and /leaderboard. So with that, congratulations for all the referral contest winners. Really appreciate all of you coming forward and helping spread the word about this conference. So in total, we received 2,304 referrals, which is amazing. So the next awaited one is the quiz winners. So we had the quiz in the afternoon from 1:40 to 1:50, and there were 187 submissions. So one of the criteria for this quiz contest is that you should you should answer all the questions correctly. So if you answer all the questions correctly, you'll get 5 points. So how many are there? We have, let me select and see how many are there. So it's 90 of you have correctly answered the questions, which is quite impressive. So what I'm doing now is we are going to do a lucky draw to decide who is the winner. So what I have done is I have copied the names and put it as an array. Let us use Python to decide who is the winner. So let's make it big screen. Go to temp directory, call Python, and we want to do random. So import random, and then we have the names, the candidates. So let's print the winners. So there are 6 winners for this contest. So we're randomly choosing using a Python program. So here we go. The drum rolls, please. The first winner is Manju, Ujjwal M, Meena, Lavanya C, Ritik Sharma. So we are 5 winners. 1, 2, 3, 4, 5 winners, and last winner is Neha T. So I will remember those winners so that we can reach out to you through the email and send the gift vouchers to you by maximum by tomorrow evening, right? So each of the winner will be getting rupees 500 worth Flipkart vouchers. Okay, so that's about the winners. So let me get back here and thank all the supporters who have been a huge support for this conference. So we had 3 wonderful days of the conference, Wednesday, Thursday, and Friday. And we thank all the speakers for sharing their knowledge, not just from India, from across the world. There have been many speakers who have shared their knowledge. Thanks so much, Aaron, Abhishek, Aditya, Anisha, Aravind, Arjun, Arpita, Chinmayi, Dave, Hamida, Harsh, Hink, Kamesh, Leena, Mamta, Menaka, Mithun, Murugan, Nancy, Niharika, Niloshima, Priyanka, Ritesh, Sandeep, Seema, Sayantika, Usha, Vishal, Vivek. Thank you so much for sharing your knowledge. Really appreciate your contribution. So we have the support of so many good people who contribute to the community. So we're really thankful to Bangalore CNCF Meetup, Being Datum Forum, Cloud Native Bangalore Meetup, Coda Plus Community, .NET Bangalore Meetup, Elastic User Group, GirlScript, India Startups Bangalore, InfoSec Girls, Kubernetes and Cloud Native Computing Pune Meetup Group, Machine Learning and Blockchain Hyderabad Group, Microsoft Artificial Intelligence Community Group, Mozilla India, ODSC Delhi, Pi Ladies Bangalore, Pi Ladies Chennai, School of AI Trivandrum, Script Foundation, Technology Cafe Bengaluru, Tinker Hub, WIDS Noida, and WIMLDS Mysore. So huge thank you for all of you. So this conference wouldn't have been possible without the support of Microsoft, and huge thanks to Microsoft Azure for sponsoring this conference, and a big thanks to Vivek and Arko for being a continuous supporter for us in all the efforts that we have taken for making this conference successful. So you please submit your feedback if you haven't already submitted yet. So the link is conf.me/feedback3, and many of you are students who want to get an attendance or participation certificate. So when you're submitting the feedback form, please mention in the feedback form that you want participation certificate, and you'll be getting it by tomorrow end at the max. So with that, thank you so much for making this conference a very big success. In the number of participants for all the 3 days, the number of live users is mostly more than 2,000, and today it was 3,300 live participants concurrently. And the number of viewers have been, for the first day, for example, it was 48,000 viewers, and and so on. So the metrics are quite really good. So the reach for the conference is possible because of the support of the speakers, the sponsors, the community organizers who have spread the word about this conference in their network, and most of all you who made this possible. So a big thanks to each and every one of you for making this conference a big success. With that, I hand over back to Rohit.
Thanks a lot, Ganesh, for announcing the winners. So anyway, like a few people are asking for the winners for the referral program. So I'll share the result once again. So guys, I hope you can see my screen. So these are the winners for our referral contest. So the top 10 winners will be reached out over their email addresses, and they'll be receiving a gift voucher. So congratulations to all of you. So if anyhow we miss out, you can surely mail us or reach out to us over Twitter, or even through the YouTube comments or anywhere, and we'll send the email to all of you. Also guys, I'd like to tell you, please subscribe to our YouTube channel so that you don't miss out for the further coming online conferences and all the tech conferences happening around. So Confirm is around tech conferences. We regularly host developer oriented events, which are meetups, conferences, and other activities as well. So you can subscribe to Confirm channel, and also you can follow our Twitter handle so to get all the updates on the upcoming events. So that will be all. Thank you all for joining us for the 3-day long conference, Cloud Community Days, and hoping to see you soon. Thank you.